bidang manusia perhubungan. Politeknik Keselamatan Transportasi Jalan, awalnya bernama Balai Diklat Transportasi Jalan Raya, berdiri pada tanggal 14 Mei 1971. Sejak tahun 2012 berubah menjadi Politeknik Keselamatan Transportasi Jalan berdasarkan Peraturan Menteri Perhubungan Nomor 15 Tahun 2012. Pendirian PKTJ adalah sejalan dengan program pemerintah yang tertuang dalam Rencana Umum Nasional Keselamatan Jalan 2011 sampai dengan 2035. PKTJ diharapkan mampu menyediakan sumber daya manusia yang berkompeten di bidang keselamatan transportasi jalan sehingga dapat membantu keberhasilan program pemerintah. Manajemen Keselamatan Transportasi Jalan atau Rekayasa Sistem Transportasi Jalan terakreditasi B. 2. Teknik Keselamatan Otomotif atau Rekayasa Perancangan Mekanik terakreditasi B. 3. D3 Pengujian Kendaraan Bermotor atau Teknologi Mekanika Otomotif terakreditasi. Metode pembelajaran di Politeknik Keselamatan Transportasi Jalan. Sebagai perguruan tinggi vokasional, pembelajaran di PKTJ memiliki proporsi 30% teori dan 70% praktek. Metode pembelajaran di PKTJ meliputi klasikal, latihan, simulasi, kunjungan lapangan, praktikum, kuliah umum, dan magang atau praktek kerja profesi.
Cita-cita menjadi seorang taruna, berdiri tegap gagah perkasa, tunaikan tugas yang mulia. bangga. Kini aku sedang ditempa oleh pelatih dan pembina. Lupa kawan, lupa saudara, lupakanlah saja semuanya. Saya tahan sakit-sakit, tidak masuk rumah sakit. Saya tahan menderita siang malamku ditempa. Walau diriku ditempa, hatiku selalu gembira, gembira, gembira selamanya. Bergembira senantiasa, selalu gembira. Hilangkanlah rasa susah sejauh-jauhnya. Rasa susah dan rasa sedih tiada gunanya. Berletih dan bergembira, Garuda tetap jaya. Bangun pagi-pagi menuju ke lapangan untuk mengikuti latihan dan latihan. Tak tahan rasanya ingin segera pulang, pendidikan belum usai. Mau makan jalan jongkok, habis makan lompat kodok. Caciku dimakiku dibentak-bentak. Wahai pelatihku, betapa kejam dirimu. Wahai pelatihku, betapa jeli matamu. Andaikan engkau tahu apa isi hatiku. Ku sayang padamu, ku cinta padamu. Tatap mata yang tajam, sikap penuh wibawa, semangat berkobar di dada. Berat sama dipikul, ringan sama dijinjing. Kami taruna PKTJ, walau guntur menggelegar, diiringi angin topan hujan badai. Tak dihiraukan PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu. Walau guntur menggelegar, diiringi angin topan hujan badai. Tak dihiraukan PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu. PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu. Kami taruna PKTJ, walau guntur menggelegar, diiringi angin topan hujan badai. Tak dihiraukan PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu. Walau guntur menggelegar, diiringi angin topan hujan badai. Tak dihiraukan PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu.
Jabat tanganku, mungkin untuk yang terakhir kali kita berbincang tentang memori di masa itu. Peluk tubuhku, usapkan juga air mataku. Kita terharu, seakan tiada bertemu lagi. Bersenang-senanglah, karena hari ini yang kan kita rindukan di hari nanti. Sebuah kisah klasik untuk masa depan. Bersenang-senanglah, karena hari ini yang kan kita banggakan di hari tua. Oh, Sampai jumpa kawanku, semoga kita selalu menjadi sebuah kisah klasik untuk masa depan. Sampai jumpa kawanku, semoga kita selalu menjadi sebuah kisah klasik untuk masa depan. Bersenang-senanglah karena hari ini yang kan kita rindukan di hari tua. Oh, sampai jumpa kawanku, semoga kita selalu menjadi sebuah kisah klasik untuk masa depan. Sampai jumpa
selalu untuk kesedaran PKTJ 2020 semuanya PNS. Amin.
Tak terasa waktu begitu cepat berlalu. Kebersamaan yang begitu indah kini sebentar lagi tidak akan ditemui lagi. Dulu kalian setiap hari selalu bersama, bertatap muka dan menciptakan cerita, menyusun rancangan harapan dan cita-cita, berharap suatu saat bisa terwujud. Selamat wisuda kepada Taruna-taruni PKTJ, selamat datang ke gerbang kehidupan baru. Ini bukanlah akhir dari perjuangan kalian. Tetap semangat, berkiprah di dunia nyata dan mengabdikan diri kepada masyarakat. Bawalah nama baik diri kalian dan PKTJ.
Masih ingin bersama kalian, mungkin jiwaku masih haus sanjungan kalian.
Badan Pengembangan Sumber Daya Manusia Perhubungan, BPSDM Perhubungan. Republik Indonesia adalah negara kepulauan terbesar di dunia. Terletak sangat strategis di antara dua benua dan dua samudra. Penduduk Indonesia yang mencapai lebih dari 260 juta merupakan potensi dan faktor terpenting yang harus terus dikembangkan kualitasnya agar mampu membawa negara kesatuan ini menjadi bangsa yang modern, maju, dan mandiri. Dengan kondisi geografis, demografis, dan berbagai potensi yang dimiliki bangsa ini, transportasi menjadi kebutuhan dasar yang sangat vital. Saat ini, Kementerian Perhubungan gencar membangun berbagai infrastruktur transportasi dan mengembangkan sistem pelayanan transportasi nasional untuk mewujudkan keterpaduan pelayanan antar moda transportasi. Kualitas profesional sumber daya manusia transportasi berperan sangat vital untuk mewujudkan pelayanan transportasi yang handal dan berdaya saing tinggi, sehingga sektor transportasi dapat menjalankan perannya sebagai urat nadi kehidupan masyarakat dan bangsa. Badan Pengembangan Sumber Daya Manusia Perhubungan adalah pelaksana teknis Kementerian Perhubungan yang bertanggung jawab menyediakan dan mengembangkan sumber daya manusia di bidang transportasi. Dalam melaksanakan tugasnya membentuk insan transportasi yang prima, profesional, dan beretika, BPSDM Perhubungan mengedepankan interaksi aktif dengan seluruh stakeholder secara intensif dan berkesinambungan melalui pendekatan inovasi quadruple helix, melibatkan partisipasi pihak akademik, pelaku usaha, pemerintah, dan masyarakat. Saat ini, sektor transportasi telah memasuki era globalisasi yang sesungguhnya dan menghadapi berbagai tantangan besar, seperti pemberlakuan ASEAN Free Trade Area, tantangan mengantisipasi pergeseran fundamental ke arah aplikasi digital yang serba cepat dan berskala internasional, dan tantangan mewujudkan pelayanan berbasis smart and green transportation yang terintegrasi dan ramah lingkungan. Dalam upaya mempersiapkan cikal SDM transportasi masa depan yang tangguh, cerdas, dan memiliki kecepatan beradaptasi terhadap perubahan teknologi, BPSDM Perhubungan melaksanakan proses seleksi penerimaan calon taruna yang ketat, terdiri dari tahap seleksi akademik, psikotes, seleksi kesehatan, seleksi kesamaptaan, dan seleksi wawancara. Program Masa Dasar Pembentukan Karakter Calon Taruna atau Madatukar adalah candra di muka untuk melatih sikap dasar pantang menyerah, disiplin, kerja keras, dan kerja sama. Sikap mental ini akan menjadi karakter dasar dan yang paling utama untuk menjadi insan transportasi yang unggul. Program Madatukar dilaksanakan di Balai Pendidikan Pelatihan dan Pengembangan Karakter Transportasi, Pasir Jambu, Bandung. Fasilitas balai di bawah BPSDM Perhubungan ini dirancang khusus untuk melaksanakan program pembentukan karakter yang diharapkan dapat menanamkan semangat kebangsaan, kerjasama, dan lahirnya insan perhubungan masa depan yang berhati Indonesia. Ketarunaan dan pola asuh disiplin around the clock adalah ciri khas pendidikan dan pelatihan transportasi. Taruna dan taruni wajib tinggal di asrama agar mereka lebih sempurna menyerap ilmu dan skill transportasi serta lebih cepat membentuk karakter yang menjadi ciri khas insan perhubungan, yaitu kemampuan mengamalkan 5 citra manusia perhubungan. BPSDM Perhubungan memiliki unit pelaksana teknis yang terdiri dari Politeknik, Akademi, dan Balai yang tersebar di berbagai wilayah Indonesia. Dalam rangka membangun organisasi pendidikan vokasi yang berkelas internasional, seluruh unit pelaksana teknis transportasi darat, laut, dan udara ini memiliki fasilitas pendidikan yang lengkap, modern, dan berbasis teknologi transportasi terbaru dan berstandar internasional. Kurikulum diklat dirancang link and match dengan kebutuhan dan perkembangan di industri transportasi. Instruktur adalah aktor utama untuk menjamin transfer of knowledge dan transfer of values di sektor transportasi. Seluruh materi diklat disajikan oleh instruktur berpengalaman, ahli, dan bersertifikat internasional. Instruktur ini merupakan ujung tombak untuk membentuk insan transportasi yang profesional dan berdaya saing tinggi. Insan transportasi yang mampu mengutamakan keselamatan dan keamanan transportasi serta pelayanan prima. Pusat Pengembangan SDM Perhubungan Darat adalah unit kerja di bawah BPSDM Perhubungan yang mempunyai tugas melaksanakan pembinaan teknis dan pengembangan sumber daya manusia di bidang transportasi darat dan perkereta-apian. Unit pelaksana teknis matra darat adalah Politeknik Transportasi Darat Indonesia atau STTD Bekasi, Politeknik Keselamatan Transportasi Jalan, Tegal, Politeknik Transportasi Sungai, Danau, dan Penyeberangan, Palembang, Politeknik Perkereta-apian Indonesia, Madiun, Politeknik Transportasi Darat, Bali, Balai Pendidikan dan Pelatihan Transportasi Darat, Mempawah.
Wahana
Bakti.
Pusat Pengembangan SDM Perhubungan Laut bertugas melaksanakan pembinaan teknis dan pengembangan sumber daya manusia di bidang transportasi laut. Unit pelaksana teknis matra laut adalah Sekolah Tinggi Ilmu Pelayaran Jakarta, Politeknik Ilmu Pelayaran Semarang, Politeknik Ilmu Pelayaran Makassar, Politeknik Pelayaran Malahayati Aceh, Politeknik Pelayaran Sumatera Barat, Politeknik Pelayaran Surabaya, Politeknik Pelayaran Banten, Politeknik Pelayaran Barombong, Politeknik Pelayaran Sulawesi Utara, Politeknik Pelayaran Sorong, Balai Besar Pendidikan, Penyegaran, dan Peningkatan Ilmu Pelayaran Jakarta, Balai Pendidikan dan Pelatihan Transportasi Laut Jakarta.
We are the best, Jalan.
Pusat Pengembangan SDM Perhubungan Udara bertugas melaksanakan pembinaan teknis dan pengembangan sumber daya manusia di bidang penerbangan. Dalam menghadapi tantangan globalisasi di dunia penerbangan, Unit Pelaksana Teknis Matra Udara terus berupaya meningkatkan kualitas pendidikan untuk menghasilkan SDM transportasi udara yang tangguh. Unit Pelaksana Teknis di Matra Udara adalah Politeknik Penerbangan Indonesia Curug, Politeknik Penerbangan Surabaya, Politeknik Penerbangan Medan, Politeknik Penerbangan Makassar, Politeknik Penerbangan Palembang, Politeknik Penerbangan Jayapura, Akademi Penerbang Indonesia Banyuwangi, Balai Pendidikan dan Pelatihan Penerbangan Curug.
Saya bagian dari beasiswa 3T pemerintah pusat.
Setelah saya jadi pilot, saya ingin mengabdi di Papua.
Dalam rangka implementasi program prioritas Nawacita tentang pemerataan kesempatan pendidikan tinggi, BPSDM Perhubungan melaksanakan program beasiswa unggulan 3T. Program beasiswa ini bertujuan memberi kesempatan kepada putra-putri terbaik lulusan SMA atau sederajat di wilayah terdepan, terluar, dan terpencil untuk menjadi taruna transportasi. BPSDM Perhubungan juga berkontribusi melaksanakan program diklat pemberdayaan masyarakat dengan memberi pelatihan keahlian terapan pada masyarakat di usia produktif. Sebagai instansi teknis di lingkungan Kementerian Perhubungan, BPSDM Perhubungan mendorong setiap unit pelaksana teknisnya untuk menjadi badan layanan umum. Dengan penetapan sebagai badan layanan umum, setiap UPT diharapkan lebih leluasa meningkatkan pelayanan kepada masyarakat seluas-luasnya dalam rangka mencerdaskan kehidupan bangsa. Aparatur perhubungan adalah garda terdepan dan berperan sangat vital sebagai perencana, pelaksana, dan pengawas pelayanan transportasi di masyarakat. Pusat Pengembangan SDM Aparatur Perhubungan adalah unit pelaksana teknis BPSDM Perhubungan yang bertugas meningkatkan kompetensi teknis dan manajerial profesional. Pusbang Aparatur Perhubungan ini merupakan kawah candra di muka untuk mempersiapkan para calon pemimpin aparatur Kementerian Perhubungan. The best leader are trained here. Pelantikan perwira transportasi adalah puncak pencapaian akademik taruna dan taruni transportasi. Mereka telah ditempa secara fisik, mental, dan akademik untuk menjadi kader insan perhubungan yang mampu mengamalkan 5 citra manusia perhubungan. Baktimu telah dinanti, bangkitkan semua kemampuan. Mari kita bangun bangsa ini. Badan Pengembangan Sumber Daya Manusia Perhubungan, BPSDM Perhubungan. Republik Indonesia adalah negara kepulauan terbesar di dunia. Terletak sangat strategis di antara 2 benua dan 2 samudra. Penduduk Indonesia yang mencapai lebih dari 260 juta merupakan potensi dan faktor terpenting yang harus terus dikembangkan kualitasnya agar mampu membawa negara kesatuan ini menjadi bangsa yang modern, maju, dan mandiri. Dengan kondisi geografis, demografis, dan berbagai potensi yang dimiliki bangsa ini, transportasi menjadi kebutuhan dasar yang sangat vital. Saat ini, Kementerian Perhubungan gencar membangun berbagai infrastruktur transportasi dan mengembangkan sistem pelayanan transportasi nasional untuk mewujudkan keterpaduan pelayanan antar moda transportasi. Kualitas profesional sumber daya manusia transportasi berperan sangat vital untuk mewujudkan pelayanan transportasi yang handal dan berdaya saing tinggi, sehingga sektor transportasi dapat menjalankan perannya sebagai urat nadi kehidupan masyarakat dan bangsa. Badan Pengembangan Sumber Daya Manusia Perhubungan adalah pelaksana teknis Kementerian Perhubungan yang bertanggung jawab menyediakan dan mengembangkan sumber daya manusia di bidang transportasi. Dalam melaksanakan tugasnya membentuk insan transportasi yang prima, profesional, dan beretika, BPSDM Perhubungan mengedepankan interaksi aktif dengan seluruh stakeholder secara intensif dan berkesinambungan melalui pendekatan inovasi quadruple helix, melibatkan partisipasi pihak akademik, pelaku usaha, pemerintah, dan masyarakat. Saat ini, sektor transportasi telah memasuki era globalisasi yang sesungguhnya dan menghadapi berbagai tantangan besar, seperti pemberlakuan ASEAN Free Trade Area, tantangan mengantisipasi pergeseran fundamental ke arah aplikasi digital yang serba cepat dan berskala internasional, dan tantangan mewujudkan pelayanan berbasis smart and green transportation yang terintegrasi dan ramah lingkungan. Dalam upaya mempersiapkan cikal SDM transportasi masa depan yang tangguh, cerdas, dan memiliki kecepatan beradaptasi terhadap perubahan teknologi, BPSDM Perhubungan melaksanakan proses seleksi penerimaan calon taruna yang ketat, terdiri dari tahap seleksi akademik, psikotes, seleksi kesehatan, seleksi kesamaptaan, dan seleksi wawancara. Program Masa Dasar Pembentukan Karakter Calon Taruna atau Madatukar adalah candra di muka untuk melatih sikap dasar pantang menyerah, disiplin, kerja keras, dan kerjasama. Sikap mental ini akan menjadi karakter dasar dan yang paling utama untuk menjadi insan transportasi yang unggul. Program Madatukar dilaksanakan di Balai Pendidikan Pelatihan dan Pengembangan Karakter Transportasi Pasir Jambu, Bandung. Fasilitas balai di bawah BPSDM Perhubungan ini dirancang khusus untuk melaksanakan program pembentukan karakter yang diharapkan dapat menanamkan semangat kebangsaan, kerjasama, dan lahirnya insan perhubungan masa depan yang berhati Indonesia. Ketarunaan dan pola asuh disiplin around the clock adalah ciri khas pendidikan dan pelatihan transportasi. Taruna dan taruni wajib tinggal di asrama agar mereka lebih sempurna menyerap ilmu dan skill transportasi serta lebih cepat membentuk karakter yang menjadi ciri khas insan perhubungan, yaitu kemampuan mengamalkan 5 citra manusia perhubungan. BPSDM Perhubungan memiliki unit pelaksana teknis yang terdiri dari Politeknik, Akademi, dan Balai yang tersebar di berbagai wilayah Indonesia. Dalam rangka membangun organisasi pendidikan vokasi yang berkelas internasional, seluruh unit pelaksana teknis transportasi darat, laut, dan udara ini memiliki fasilitas pendidikan yang lengkap, modern, dan berbasis teknologi transportasi terbaru dan berstandar internasional. Kurikulum diklat dirancang link and match dengan kebutuhan dan perkembangan di industri transportasi. Instruktur adalah aktor utama untuk menjamin transfer of knowledge dan transfer of values di sektor transportasi. Seluruh materi diklat disajikan oleh instruktur berpengalaman, ahli, dan bersertifikat internasional. Instruktur ini merupakan ujung tombak untuk membentuk insan transportasi yang profesional dan berdaya saing tinggi. Insan transportasi yang mampu mengutamakan keselamatan dan keamanan transportasi serta pelayanan prima. Pusat Pengembangan SDM Perhubungan Darat adalah unit kerja di bawah BPSDM Perhubungan yang mempunyai tugas melaksanakan pembinaan teknis dan pengembangan sumber daya manusia di bidang transportasi darat dan perkereta apian. Unit pelaksana teknis matra darat adalah Politeknik Transportasi Darat Indonesia atau STTD Bekasi, Politeknik Keselamatan Transportasi Jalan Tegal, Politeknik Transportasi Sungai, Danau, dan Penyeberangan Palembang, Politeknik Perkereta Apian Indonesia Madiun, Politeknik Transportasi Darat Bali, Balai Pendidikan dan Pelatihan Transportasi Darat Mempawah.
Wahana
Bakti.
Pusat Pengembangan SDM Perhubungan Laut bertugas melaksanakan pembinaan teknis dan pengembangan sumber daya manusia di bidang transportasi laut. Unit pelaksana teknis matra laut adalah Sekolah Tinggi Ilmu Pelayaran Jakarta, Politeknik Ilmu Pelayaran Semarang, Politeknik Ilmu Pelayaran Makassar, Politeknik Pelayaran Malahayati Aceh, Politeknik Pelayaran Sumatera Barat, Politeknik Pelayaran Surabaya, Politeknik Pelayaran Banten, Politeknik Pelayaran Barombong, Politeknik Pelayaran Sulawesi Utara, Politeknik Pelayaran Sorong, Balai Besar Pendidikan, Penyegaran, dan Peningkatan Ilmu Pelayaran Jakarta, Balai Pendidikan dan Pelatihan Transportasi Laut Jakarta.
We are the best Ciberut.
Pusat Pengembangan SDM Perhubungan Udara bertugas melaksanakan pembinaan teknis dan pengembangan sumber daya manusia di bidang penerbangan. Dalam menghadapi tantangan globalisasi di dunia penerbangan, Unit Pelaksana Teknis Matra Udara terus berupaya meningkatkan kualitas pendidikan untuk menghasilkan SDM transportasi udara yang tangguh. Unit Pelaksana Teknis di Matra Udara adalah Politeknik Penerbangan Indonesia Curug, Politeknik Penerbangan Surabaya, Politeknik Penerbangan Medan, Politeknik Penerbangan Makassar, Politeknik Penerbangan Palembang, Politeknik Penerbangan Jayapura, Akademi Penerbang Indonesia Banyuwangi, Balai Pendidikan dan Pelatihan Penerbangan Curug.
Saya bagian dari beasiswa 3T pemerintah pusat.
Setelah saya jadi pilot, saya ingin mengabdi di Papua.
Dalam rangka implementasi program prioritas Nawacita tentang pemerataan kesempatan pendidikan tinggi, BPSDM Perhubungan melaksanakan program beasiswa unggulan 3T. Program beasiswa ini bertujuan memberi kesempatan kepada putra-putri terbaik lulusan SMA atau sederajat di wilayah terdepan, terluar, dan terpencil untuk menjadi taruna transportasi. BPSDM Perhubungan juga berkontribusi melaksanakan program diklat pemberdayaan masyarakat dengan memberi pelatihan keahlian terapan pada masyarakat di usia produktif. Sebagai instansi teknis di lingkungan Kementerian Perhubungan, BPSDM Perhubungan mendorong setiap unit pelaksana teknisnya untuk menjadi badan layanan umum. Dengan penetapan sebagai badan layanan umum, setiap UPT diharapkan lebih leluasa meningkatkan pelayanan kepada masyarakat seluas-luasnya dalam rangka mencerdaskan kehidupan bangsa. Aparatur perhubungan adalah garda terdepan dan berperan sangat vital sebagai perencana, pelaksana, dan pengawas pelayanan transportasi di masyarakat. Pusat Pengembangan SDM Aparatur Perhubungan adalah unit pelaksana teknis BPSDM Perhubungan yang bertugas meningkatkan kompetensi teknis dan manajerial profesional. Pusbang Aparatur Perhubungan ini merupakan kawah candra di muka untuk mempersiapkan para calon pemimpin aparatur Kementerian Perhubungan. The best leader are trained here. Pelantikan perwira transportasi adalah puncak pencapaian akademik taruna dan taruni transportasi. Mereka telah ditempa secara fisik, mental, dan akademik untuk menjadi kader insan perhubungan yang mampu mengamalkan 5 citra manusia perhubungan. Baktimu telah dinanti, bangkitkan semua kemampuan. Mari kita bangun bangsa ini.
Politeknik Keselamatan Transportasi Jalan merupakan lembaga pendidikan vokasional di bawah pembinaan Badan Pengembangan Sumber Daya Manusia Perhubungan. Politeknik Keselamatan Transportasi Jalan awalnya bernama Balai Diklat Transportasi Jalan Raya, berdiri pada tanggal 14 Mei 1971. Sejak tahun 2012 berubah menjadi Politeknik Keselamatan Transportasi Jalan berdasarkan Peraturan Menteri Perhubungan Nomor 15 Tahun 2012. Pendirian PKTJ adalah sejalan dengan program pemerintah yang tertuang dalam Rencana Umum Nasional Keselamatan Jalan 2011 sampai dengan 2035. PKTJ diharapkan mampu menyediakan sumber daya manusia yang berkompeten di bidang keselamatan transportasi jalan sehingga dapat membantu keberhasilan program pemerintah. Keselamatan Otomotif atau Rekayasa Perancangan Mekanik, terakreditasi B. D3 Pengujian Kendaraan Bermotor atau Teknologi Mekanika Otomotif, terakreditasi B. Metode pembelajaran di Politeknik Keselamatan Transportasi Jalan. Sebagai perguruan tinggi vokasional, pembelajaran di PKTJ memiliki proporsi 30% teori dan 70% praktek. Metode pembelajaran di PKTJ meliputi klasikal, latihan, simulasi, kunjungan lapangan, praktikum, kuliah umum, dan magang atau praktek kerja profesi. Politeknik Keselamatan Transportasi Jalan merupakan lembaga pendidikan vokasional di bawah pembinaan Badan Pengembangan Sumber Daya Manusia Perhubungan. Politeknik Keselamatan Transportasi Jalan awalnya bernama Balai Diklat Transportasi Jalan Raya, berdiri pada tanggal 14 Mei 1971. Sejak tahun 2012 berubah menjadi Politeknik Keselamatan Transportasi Jalan berdasarkan Peraturan Menteri Perhubungan Nomor 15 Tahun 2012. Pendirian PKTJ adalah sejalan dengan program pemerintah yang tertuang dalam Rencana Umum Nasional Keselamatan Jalan 2011 sampai dengan 2035. PKTJ diharapkan mampu menyediakan sumber daya manusia yang berkompeten di bidang keselamatan transportasi jalan, sehingga dapat membantu keberhasilan program pemerintah. Manajemen Keselamatan Transportasi Jalan atau Rekayasa Sistem Transportasi Jalan, terakreditasi B. Teknik Keselamatan Otomotif atau Rekayasa Perancangan Mekanik, terakreditasi B. D3 Pengujian Kendaraan Bermotor atau Teknologi Mekanika Otomotif, terakreditasi B. Politeknik Keselamatan Transportasi Jalan. Sebagai perguruan tinggi vokasional, pembelajaran di PKTJ memiliki proporsi 30% teori dan 70% praktek. Metode pembelajaran di PKTJ meliputi klasikal, latihan, simulasi, kunjungan lapangan, praktikum, kuliah umum, dan magang atau praktek kerja profesi.
Cita-cita menjadi seorang taruna, berdiri tegap gagah perkasa, tunaikan tugas yang mulia, langkah tegap penuh wibawa, semangat yang tak kunjung padam, tunaikan tugas para perwira, tunaikan dengan penuh rasa bangga. Saja semuanya, saya tahan sakit-sakit, tidak masuk rumah sakit, saya tahan menderita siang malamku ditempa, walau diriku ditempa, hatiku selalu gembira, gembira, gembira selamanya, bergembira senantiasa, selalu gembira, hilangkanlah rasa sejauh-jauhnya, rasa susah dan rasa sedih tiada gunanya, berletih dan bergembira, Garuda tetap jaya. Bangun pagi-pagi menuju ke lapangan untuk mengikuti latihan dan latihan. Tak tahan rasanya ingin segera pulang, pendidikan belum usai. Mau makan jalan jongkok, habis makan lompat kodok, ku dicaci, ku dimaki, ku dibentak-bentak. Wahai pelatihku, betapa kejam dirimu, wahai pelatihku, betapa jeli matamu. Andaikan engkau tahu apa isi hatiku, ku sayang padamu, ku cinta padamu. Tatap mata yang tajam, sikap penuh wibawa, semangat berkobar di dada. Berat sama dipikul, ringan sama dijinjing. Kami taruna PKTJ, walau guntur menggelegar, diiringi angin topan hujan badai, tak dihiraukan. PKTJ berani, PKTJ perkasa, PKTJ PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu. Kami taruna PKTJ, walau guntur menggelegar diiringi angin topan hujan badai, tak dihiraukan. PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu. Walau guntur menggelegar diiringi angin topan hujan badai, tak dihiraukan. PKTJ, berani PKTJ, perkasa PKTJ, berjayalah selalu.
A very good morning to everyone in London and a very good afternoon to everyone in Indonesia. His Excellency, Minister of Transportation, Republic of Indonesia, Mr. Budi Karya Sumadi. His Excellency, the Ambassador of the Republic Indonesia to the United Kingdom. His Excellency, Deputy Head of United Kingdom to Republic of Indonesia. The Honorable Acting Head of Human Resource Development Agency on Transportation, the Honorable Head of Human Resource Development Center of Land Transportation, the Honorable Director General of Land Transportation, MOT, Indonesia, the Honorable Chairman, Indonesia Electric Vehicle Program, the Honorable Professor at University of Nottingham, the Honorable Associate Professor at University of Nottingham, the Honorable Vice President and Chief Operating Officer of Hyundai Motor Asia Pacific, the Honorable President Director of the State Electricity Company, the Honorable Official of the Ministry of Transportation, distinguished delegates, ladies and gentlemen. My name is Gina, and it is a privilege and a big honor for me to be your Master of Ceremony on this very special occasion of International Webinar of Safer Electric Vehicle. His Excellencies, distinguished delegates, ladies and gentlemen, as a start of our opening event, we will sing the national anthem of the Republic of Indonesia. We would like to request you to arise. Please be seated. Now we move on to speech segment that is going to be started with the activity report of International Webinar. Please be invited the Head of Human Resource Development Center of Land Transportation, Engineer Imran Rashid, MBA.
Bismillahirrahmanirrahim. Excellencies, Minister of Transportation, the Republic of Indonesia, Mr. Budi Karya Sumadi. Ambassador of the Republic of Indonesia to the United Kingdom, Mr. Destra Percaya. Deputy Head of Indonesia and Timor-Leste, Mr. Rob Penn. Honorable Acting Head of Human Resources Development Agency on Transportation, Mr. Zulfikri. Honorable Director General of Land Transportation, Mr. Budi Setiadi. Distinguished speakers, Professor Satria Sumantri Brojo Negoro, Chairman of Indonesia Electric Vehicle Acceleration Program, Professor Patrick Wheeler from University of Nottingham, United Kingdom, Dr. Tony Ferry, University of Nottingham, Mr. Lee Kang-yoon, Vice President and COO of Hyundai Motor Asia Pacific, Mr. Zulkifli Zaini, President Director of the State Electricity Company, PLN. Distinguished Moderator, Dr. Bagus Mulyadi from University of Nottingham, United Kingdom. Distinguished participants, delegates, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Peace be upon us. Salam, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good afternoon and good morning in United Kingdom. First and foremost, let us express our gratitude to the God Almighty. Because of His abundance of grace, we can conduct and organize the international webinar of safer vehicles, safer electric vehicles. In this great opportunity, I'd like to express my honor to the Minister of Transportation, the Republic of Indonesia, who is willing to attend the opening of the event and deliver the keynote speech. This international webinar is a series of events to celebrate the 19th anniversary of PKTJ, Politeknik, Keselamatan, Transportasi, Jalan, and the follow-up to the letter of intent between PKTJ and the University of Nottingham, United Kingdom. This collaboration continued with weekly meeting activities to discuss matters related to electric vehicles. From the weekly meetings, an agreement emerged to conduct focus group discussion activities and this webinar. Furthermore, we proudly announced that we have honorable speakers from industrial experts, academics, and professionals joining this seminar, namely Chairman of Indonesia Electric Vehicle Acceleration Program, University of Nottingham, Vice President and COO of Hyundai Motor Asia Pacific, and President Director of the State Electricity Company, PLN. The participants of this webinar consisted of invited guests, the academic community, and PKTJ alumni, the University of Nottingham academic community, Politekniks within the Land Transportation Human Development Center, the Ministry of Transportation, Land Transportation Management Center, BPTD, Association of Motorized Vehicle Inspection in Indonesia, IPKBI, Motor Vehicle Companies and Associations, academics, and the general public. The output we expect from this activity are, firstly, the concept of safer electric vehicle, including battery technology, transmission system, and safety aspect of electric vehicles. Secondly, standards for electric vehicle inspection, periodical inspection, and type approval, including the components of being inspected, the inspection system, and the competence of the inspectors. Distinguished participants, guests, ladies and gentlemen, as an education institution that concerns in the field of human resources development, the Human Resources Development Agency on Transportation, BPSDM Perhubungan, and Politeknik of Road Transportation Safety, PKTJ as well, are trying to take part in promoting electric vehicles program in Indonesia by intensely preparing competent human resources, both in the form of education and training, as well as integrating it into existing study programs. Finally, we hope this webinar will be of professional and personal benefit to all of us as we proceed with our work towards a safe road transportation system, especially safer electric vehicles. That's all of our report. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Insinyur Imran Rashid, MBA, for the activity report. Now, please be invited His Excellency, the Deputy Head of United Kingdom to Republic of Indonesia, to deliver his speech.
Thank you. I wonder where you got that photo. Honourable Minister, it's great to be sharing a podium with you virtually. And my very dear colleague, the Ambassador of the Republic of Indonesia to London, Desra Percaya, always a pleasure to be in your company. Nottingham University salutes you once again for your fantastic diplomacy between UK academia and Indonesia. And great to be in the company of some captains of industry. I can share that my family is very interested in the new Hyundai Ioniq 5. Looks like a fantastic car. I also wanted to begin with a couple of words about COVID, which is keeping us online. It is generating tragic stories in Britain and in Indonesia both. Here in Jakarta, we are riding a small positive wave on the back of the UK's donation of AstraZeneca vaccine. It's a small quantity, but it's what we have at the moment, and we will keep it coming. So that is a nice topical example of how UK-Indonesia friendship and partnership is alive and well. And I do think this area of vehicular transport, green energy, electric vehicles is shaping up to be one of the most promising areas for our bilateral cooperation. So I would like to thank the Ministry of Transport for the invitation today. I wanted to salute the people of Indonesia for their resilience as we all tackle COVID-19. And I wanted to, at the same time, stress how we are not being deflected from our work. Both our governments are alive and well and looking out for their peoples. And we, I hope, will soon see light at the end of this tunnel. Turning now to decarbonization of the transport sector through electric vehicles or EVs. This is one of the key low carbon growth pathways, and this will have a direct impact on public health and safety. I am pleased that the UK is partnering with Indonesia to accelerate EV deployment through our programs assisting DKI Jakarta with electric bus deployment and with Grab and Gojek on establishing EV two-wheeler operation in the capital city. And we are also about to start work with the Ministry of Transport to expand our assistance on greening the transportation sector, including supporting EV rollout and adoption nationwide. The economic benefits of EVs are clear, and I am pleased that companies such as VR, Celis, United, Justice, Tree Electric, and Winfly, all Indonesian companies or with Indonesian manufacturing bases, are making EVs. Indonesia also has some of the world's largest nickel reserves and can take advantage of this domestically and internationally, given the importance of nickel for battery production. The Ministry of Transport has set an ambitious target of more than 500,000 EVs for its own government fleets by 2030. EVs significantly reduce greenhouse gas emissions, including numerous toxins harmful to human health emitted by petrol and diesel vehicles that we know kill millions of people a year and cost health systems billions. This is a particularly acute problem in urban areas and metropolitan cities, where a significant proportion of pollution and impact on health systems is from exposure to vehicle emissions. Turning to the bigger picture, the way electric vehicles interact with national policy around power supply and electricity generation. We are delighted to see ESDM and PLN committing to reach net zero by 2060 or by 2050 with assistance, which the UK is very glad to offer. And this will go a long way to decarbonizing the energy sector and yielding the significant economic and public health and safety benefits which are there to be taken. There are other safety benefits to EVs, of course, such as removing the risks of fire and explosion from flammable liquid fuels. And there are some risks introduced, such as those associated with repair, maintenance, and use of high voltage equipment. Although I think the main risks in terms of public health and safety is the risk to pedestrians from EVs, given that they operate at such low noise levels. So this is exactly an area in which academia and institutions like Nottingham University and the Ministry of Transport here in Indonesia can profitably focus on to make sure that we get all the benefits of electric vehicles without any of the disbenefits. 2020 public health journals on the risk of low noise, EV, in Andalusia, in Spain, for example, revealed that EVs present a 30% higher pedestrian safety risk compared to conventional vehicles under high ambient sound levels. Whereas at the low ambient sound level, EV has a 10% higher pedestrian safety risk. However, there will be policy measures that can be taken to mitigate these risks, as has been the case since the dawn of the automobile era. Pedestrian and driver safety has improved immeasurably. And I think this is where the roles of research and training for these newly introduced vehicles in Indonesia will contribute to reaching all our targets. Ensuring the public health and safety benefits, as well as the risks, are properly communicated to the public will help accelerate EV adoption and reduce the risks entailed. So to finish, accelerated transition to EVs is essential if we are to tackle the climate crisis and meet our Paris conference commitments. And in terms of public health and safety, EVs offer more benefits than risk, given emissions reductions will both reduce the devastating effects of the climate crisis and the more immediate but equally devastating effects of local air pollution. I have no doubt that today's event will launch collaborations and forge relationships that strengthen Indonesia's transport sector, charting a path towards more efficient solutions and a low carbon future that brings economic health and safety benefits for all. I wish you all a very fruitful and productive seminar, and thank you for having me.
Thank you, His Excellency, for the speech. Next, please welcome His Excellency, the Ambassador of the Republic of Indonesia to the United Kingdom, to deliver his speech.
Yang terhormat Menteri Perhubungan RI, Bapak Budi Karya Sumadi, Kepala Pusat Pengembangan SDM Perhubungan Darat, Bapak Imran Rashid, my good friend, Chargé d'Affaires, Pak Rob Van, happy to see you virtually. Esteemed panelists, Bapak Dirjen Budi Setiadi, Profesor Satrio Brojonegoro, Bapak Zulkifli Zaini, Profesor Patrick Wheeler, Dr. Tony Perry, Mr. Lee Kang-hyun, and my good friend, Dr. Bagus Mulyadi. Distinguished guests and participants, good morning from UK and good afternoon to you in Jakarta in Indonesia. Allow me to begin by congratulating Bapak Budi Karya Sumadi and the Ministry of Transportation for convening the international webinar on safer electric vehicle. This is a great example of a swift and concrete follow-up to the letter of intent between PKTJ and University of Nottingham, signed on the 6th of May only this year. I also note that this webinar is a culmination of a series of focus group discussion held earlier 2 weeks ago, involving very capable resource persons from both the UK and Indonesia. I follow closely with appreciation the recommendations that were formulated through the said FGD, namely the need for quality standards for EV components, technical principles for EV roadworthiness, regulations on motor conversion, competence for EV examiners, EV battery recycling programs, development for socially conscious EV policies, and mitigation for EV involving road accidents. The convening of this webinar is both very important and very timely for at least 3 reasons. First, Indonesia will take part at the COP26 climate conference later this year in Glasgow. Indonesia has taken notable climate actions progress to achieve its nationally determined contribution, and this is target 29% own efforts or 41% with international cooperation. Transportation in Indonesia produces almost 30% of total CO2 emissions that contribute to global warming. Thus, accelerating Indonesia's shift from fossil fuel vehicle to sustainable transportation is imperative to this achievement. The sooner is the better. Second, this webinar reflects the direction of where partnership between Indonesia and the UK will be headed for the future. Bilateral cooperation in renewables and research related to energy will continue to be prioritized and be even more important. Collaboration in human resources development on technology innovations and regulations. Third, EV cooperation showcases the importance of Indonesian diaspora academics in the UK as part of multi-track diplomacy in serving as catalysts to boost Indonesia's national research capacity, bridging the connection between research institutions and industry, and speeding up Indonesia's development efforts. Bapak Menteri yang terhormat, ladies and gentlemen, I would like to emphasize that bilateral cooperation is crucial to support Indonesia's transition towards sustainable transportation, and in turn, reflecting Indonesia's commitment towards realizing its climate goals in line with the NDC's targets, Paris Agreement principles, and UN SDGs economic, social, and environmental pillars. Finally, I believe the policy recommendation that will be set forth through this webinar will serve as important contribution to the development of Indonesia's EV and to strengthening of Indonesia and the UK's partnership. Rest assured that the Indonesian Embassy in London will be at your disposal to make sure that today's discussion will be followed up. And I look forward for a productive discussion. Thank you.
Thank you, His Excellency, for the speech. His Excellencies, distinguished delegates, ladies and gentlemen, I would like to invite Minister of Transportation Republic of Indonesia to deliver his speech and officially to open the international webinar of safer electric vehicle. Please welcome Mr. Budi Karya Sumadi.
Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Your Excellency, Ambassador of Indonesia to United Kingdom, Ireland, and the permanent representative to IMO, Mr. Desa Percaya, apa kabar Pak? Sehat-sehat di Inggris Pak? Deputy Ambassador of the United Kingdom to Republic of Indonesia, Mr. Robert Van, Honorable Acting Head of the Human Resources Development Agency, Pak Zulfikri, Honorable General of Land Transportation, Mr. Budi Tiadi, distinguished Chairman Indonesian Electric Vehicle Acceleration Program, Professor Satrio Sumatri Bojonegoro, Representative of Nottingham University, Professor Patrick Weller and Tony Perry, and Vice President and COO Hyundai Motor Asia Pacific, Mr. Lee Kang-yu. Hi, wonderful. Good afternoon. Let us praise God mightily for His blessing. We would like gather here. It's a great pleasure for me to deliver this remark at the opening ceremony of the international webinar, Safer Electric Vehicle, which conduct in commemoration of the 15th Politeknik of Road Transportation Safety PKTJ University. The government of Republic Indonesia has issued the Presidential Regulation number 55 year 2019 concerning the acceleration program of battery-based electric vehicle. As the implementation of regulation, Minister of Transportation through his training institute actively collaborating with university in advanced country for acceleration of the electric vehicle development in Indonesia. Therefore, I fully support the cooperation that has been conducted smoothly between PKTJ and Nottingham University, which formally stated in the letter of intent signed in 2021. As a follow of the LOE, PKTJ and Nottingham University have conducted some activity, among others, FGD on the safer electric vehicle held in July 2021. From the FGD, policy brief has been produced regarding the electric vehicle, which is covering the importance of the battery component system and battery chain charter, technical requirement, and roadworthiness regulation, competency of the infection, battery recycling or waste management system, and electric vehicle accident handling and mitigation. Safety is the most important aspect in the road transportation activity, as well as electric vehicle. However, efficient and economic friendly aspect also needed to be focused on. The essential, since several components and the system in the electric vehicle have the potential to pose a risk of fire and accident. Therefore, the development of electric vehicle should be carried out in the careful and detailed consideration, yet within the time frame that made and agreed by PKTJ and Nottingham University. To develop safe and efficient, as well as environmentally friendly vehicle, good cooperation and collaboration among parties such as industry, research institution, community, and government, and namely needed. While the development of electric vehicle continues to proceed, the government could also start to formulate related regulation, and at the same time, education institution can prepare the training system. I also would like to emphasize the importance of the competent human resources on the land transportation to ensure that every electric vehicle operate on the road meet the technical requirement and road quality. The webinar is conducted virtual by the Human Resources Development Agency on the Transportation, Ministry of Transportation, in collaboration with Nottingham University and the Embassy of Indonesia in London. Therefore, I appreciate the initiative of the committee for conducting this event. I hope that through this event, which intended by speaker and participants from government, academy, industry, corporation, we can generate information, creative idea, and innovation in the content of acceleration and implementation of the electric vehicle in Indonesia. Finally, I am saying Bismillahirrahmanirrahim. I am hereby officially declare the opening the International Webinar Safer electric vehicle. May God mightily always provide this guidance to all us in contributing to development of safe and eco-friendly vehicle to support energy efficient, energy security, and energy conversion in the transportation sector. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Mr. Budi Karya Sumadi, for the keynote speech. Ladies and gentlemen, before we continue, let's take a photo session together for documentation. Please turn on your camera and take a look at the camera and smile. We will start in 3, 2, 1. Once again, 3, 2, 1. A special thank you to the Minister of Transportation and other officials who were present at today's event. All participants are pleased to stay in the meeting room until the event is finished. All participants, we will continue to our main event. Allow me deliver to Dr. Bagus Muljadi from University of Nottingham to take place as our moderator for today. Without any further delay, to Dr. Bagus Muljadi, time and place are welcome.
Thank you very much, Gina. Good morning to you watching in the United Kingdom. Good afternoon to you watching in Indonesia. I would like to thank you very much again, Minister Budi Karya Sumadi, our dear friend and minister, Rob Fan, the Deputy Head of Mission. Good to see you again. Pak Dubes Desra Percaya, thank you very much again for all your support to this initiative. My name is Bagus Muljadi. I'm an assistant professor at the University of Nottingham, the coordinator of the UK-Indonesia Consortium for Interdisciplinary Sciences. And I'm delighted to be here. And I would like to also say hi to thousands of people who have tuned into this event. This is truly a testament of great collaborations between the UK and Indonesia. As has been explained before by previous speakers, climate change is real, and it's a problem that no country can face alone. And it makes me excited to moderate this event today because this event is attended by stellar lists of speakers, not only from academics, but governments, representatives, but also industries, and not only from Indonesia, but from global participants. And we have with us today the representative from the Ministry of Transportation, from University of Nottingham, Professor Patrick Wheeler. Dr. Tony Perry is with us today. The Chief Operation Officer from Hyundai Motors, Mr. Lee Kang-hyun, good to see you. The Executive Vice President of the State Electric Company, PLN, Dr. Zainal Arifin, is also with us today. Now we're going to talk more about not only climate change, but particularly the challenges in adopting electric vehicles in Indonesia. So this is something that both the UK and Indonesia have in terms of problems that they're facing moving forward. It isn't a trivial problem. We have challenges not only on the technical aspect, but also in the regulatory frameworks that supports the implementation and the uptake of EV. Over the last couple of weeks, we have collaborated with PKTJ. Thanks very much to Ibu Mai and her delegates, also to come together and to make provisions for new regulations in the safety of the electric vehicle. This is something that the UK and Indonesia face together. In terms of climate change, the UK ICIS will also conduct similar events in the beginning of September. We're going to pay our focus to the COP26, which will happen in Glasgow in October, November. So stay tuned for that event as well. So without further ado, I would like to introduce our speakers. And the first one is Bapak Rizal Wasal, Direktur Sarana Transportasi Jalan from the Ministry of Transportation. So Bapak Rizal Wasal, can you hear me?
Yes, Pak Bagus. Selamat sore. Good afternoon,
Thank
Pak
you.
Bagus.
So, yes, when you are ready, time is yours.
Okay, thank you, Pak Bagus. So, ladies and gentlemen, good afternoon. So allow me, today I will explain about the electric vehicle. First, I want to sorry Pak Bapak Direktur Jenderal Perhubungan Darat. They have another task. They give me a task to give this explanation regarding electric vehicle. So Bapak-Ibu sekalian, saya akan coba menyampaikan apa yang telah disiapkan oleh Direktur Jenderal Perhubungan Darat terkait dengan regulasi maupun pelaksanaan dari pengujian kendaraan bermotor listrik. So Pak Bagus, we use in bahasa or mix?
Mix would be great, but whatever makes you comfortable, I think. So,
okay, thank you.
Yeah.
Okay, we try to make in bahasa in English. Bapak sekalian, sebagaimana kita ketahui bahwa Republik Indonesia telah mengeluarkan, Pak Presiden sudah mengeluarkan peraturan Presiden nomor 55 tahun 2019 tentang bagaimana percepatan program kendaraan motor listrik berbasis baterai. Hal ini dengan tujuan pertama yaitu peningkatan efisiensi energi, ketahanan energi, konversi energi sektor transportasi, dan terwujudnya energi bersih, kualitas udara bersih dan ramah lingkungan, serta komitmen Indonesia menurunkan emisi gas rumah kaca. So juga memberikan guidance, memberikan arah, landasan dan kepastian hukum dalam pelaksanaan percepatan program kendaraan bermotor listrik berbasis baterai electric vehicle untuk land transportation atau transportasi jalan. And the last will be regarding mendorong penguasaan teknologi industri dan rancang bangun kendaraan serta menjadikan Indonesia sebagai basis produksi dan ekspor kendaraan motor dan baik itu kendaraan motor utama kendaraan bermotor listrik. This regulation about the Minister regulation terkait dengan percepatan program kendaraan motor listrik berbasis baterai. Pertama, telah dilakukan Peraturan Menteri Nomor 65 tahun 2020 tentang konversi sepeda motor dengan penggerak motor bakar menjadi sepeda motor listrik berbasis baterai. Apa itu regulasi ini nanti akan kami jelaskan di belakang. Yang kedua juga tentang Peraturan Menteri Perhubungan Nomor 87 tahun 2020 tentang pengujian tipe fisik kendaraan bermotor listrik berbasis baterai. Next. So, kita bicara tentang bagaimana pengujian tipe dari kendaraan bermotor listrik, sebagaimana diatur dalam Peraturan Menteri tadi nomor 87. Bapak sekalian, this is physical test and road water test untuk kendaraan bermotor pada umumnya. Ada 10 item yang akan diuji pada saat mereka menerima sertifikat uji tipe di Indonesia. Pertama, regarding the noise, kebijakan udara, masalah rem, brake efficiency, side slip, klakson, headlight, lampu utama, berat kendaraan juga dilakukan penimbangan, pengujian, kesesuaian dari mesin penggerak terhadap berat motor, begitu power ratio, ban dan roda, tire and wheel, speedometer, dan radius putar dari kendaraan tersebut. Ini masalah radius putarnya. Ini hal umum yang dilakukan untuk semua kendaraan bermotor yang akan masuk ke Indonesia diuji seperti ini. Lanjut. Nah, untuk kendaraan listriknya, ada beberapa tambahan addition of physical type untuk kendaraan motor listrik. Pertama terkait dengan ujuk kerja atau profil dari baterai atau baterai safety-nya. Yang kedua terkait dengan alat pengisian ulang atau reservoir plug yang tadi yang akan juga kami uji. Selanjutnya tentang uji kemampuan pelindungan satu listrik, protection agent context yang kita lakukan uji. Selanjutnya juga kita menguji tambahan terkait functional safety. Juga kita uji tentang emission hydrogen for lead acid battery, ini dengan emisi hidrogennya, dan terakhir juga kita lakukan uji suara atau sound level. ada sedikit perbedaan uji suara pada kendaraan bermotor baterai dengan kendaraan motor yang menggunakan minyak. Pada saat ini untuk uji baterai ini kita mencoba bagaimana kendaraan motor listrik sedikit mengeluarkan suara hingga masyarakat atau orang yang sekitar tahu bahwa di sekitarnya ada kendaraan bermotor. Baik. Ini nanti kita akan bicara beberapa aktivitas yang telah dilakukan oleh Kementerian Perhubungan untuk bagaimana mendukung kendaraan motor tadi, selain tadi dikeluarkannya regulasi kurasi terkait dengan kendaraan motor listrik. Pertama, until now, Ministry of Transportation have used more than 30 BIF kendaraan motor listrik untuk kendaraan operasional, untuk pimpinan. Yang kedua juga kita sudah melakukan e-katalog untuk kendaraan tersebut menggunakan e-katalog. Selanjutnya kita Indonesia ready untuk melakukan pengujian untuk kendaraan listrik, baik untuk sepeda motor, baik untuk kendaraan mobil listrik. Dan dalam rangka perkembangan alat uji, kita sedang mengembangkan sistem KPBU untuk mengingatkan Proviground yang ada di Bekasi ini dengan melengkapi alat uji untuk WNL 138 dan terkait uji suara mobil listrik pada BPJSKB atau Balai Ujian Layak Jalan Sertifikasi Bermotor. Next, please. Nah, ini regarding physical intensive for vehicle type test fee. Kita memberikan insentif untuk kendaraan bermotor listrik tadi. Kalau sepeda motor untuk yang bahan bakar minyak tadi 9,5 juta, maka untuk listrik hanya separuhnya, 4,5 juta. Untuk mobil penumpang biayanya 20 juta, maka untuk mobil listrik hanya 13,2 juta. Untuk bus yang bahan bakar fosil tadi 120 juta, maka untuk yang listrik itu hanya 13,2 juta untuk biaya uji tipe dari kendaraan tersebut. Next. Ini tarif untuk SRUT. Bapak sekalian, Indonesia after they have SUT, sertifikat uji tipe, they must have SRUT. Sertifikat uji tipe per kendaraannya. Juga kita memberikan insentif untuk ini. Untuk sepeda motor yang kalau berdasarkan PP yang 2016 biaya 50 juta, kita usulkan 25 juta untuk kendaraan motor, dan untuk kendaraan motor listrik maksimum biayanya hanya 1 juta. Sementara untuk mobil dan landasan awalnya 70 juta, kita usulkan ke 30 juta, dan untuk listrik kita usulkan hanya 5 juta untuk biaya SRUT per kendaraannya. This is a number of jumlah kendaraan listrik yang sudah beroperasi di Indonesia, yang sudah memiliki SRUT. Ada beberapa jenis tipenya. Untuk car, mobil penumpang roda 4 itu ada 43 SUT dengan 2012 kendaraan yang sudah beroperasi atau sudah memiliki SRUT. Untuk roda 3, kami juga melaksanakan roda 3, kebanyakan lebih kepada untuk kendaraan angkutan barang. Itu ada 6 SUT dengan 76 kendaraan yang sudah beroperasi. Yang sepeda motor kami cukup banyak. Dari 50 SUT sertifikat yang dimiliki itu ada 5.486 yang sudah berada di jalan sepeda motor di Indonesia ini yang motor listrik. Mobil bus ada 8 sertifikat dengan 10 kendaraan yang telah memiliki SRUT bus. Mobil barang 1 SRUT dengan 1 SRUT, 1 kendaraan baru ada. Sementara yang landasan baru memiliki SUT, tapi mereka belum memproduksi kendaraannya, juga termasuk landasan mobil barang tadi, landasan mobil barang. Ini jumlah kendaraan yang sudah listrik yang sudah ada di Indonesia yang telah memiliki SRUT, sudah memiliki SUT-nya. Next. Lanjutnya kita mencoba tentang konversi dari kendaraan komersial motorcycle into the battery-based electric motorcycle. Sebagaimana tadi kami sampaikan lagi bahwa Kementerian Perhubungan juga sudah mengeluarkan peraturan menteri nomor PM65 tahun 2000 bagaimana kita bisa mengkonversi kendaraan bermotor minyak tadi menjadi kendaraan bermotor sepeda motor listrik. Next, please. Tadi, Bapak-Ibu sekalian, ini setiap kendaraan bermotor dengan penggerak motor bakar yang telah dilakukan yang telah dilakukan registrasi dan verifikasi dapat dilakukan konversi menjadi motor listrik. Jadi every conversion motorcycle that has been registered and identified can be converted into the battery-based electric motorcycle. Jadi hanya kendaraan yang telah memiliki surat atau SUT sertifikat diperbolehkan untuk melakukan konversi. Selainnya tidak boleh. Oke. Next. This is for the persyaratan dari bengkel umum konversi. Yeah, convention general workshop only carried out by public workshop, hanya bisa dilakukan oleh bengkel umum yang telah mendapat persetujuan dari Menteri melalui Direktur Jenderal Perhubungan Darat sebagai bengkel konversi. Jadi tidak semua bengkel umum bisa melakukan, tapi hanya bengkel yang mendapat persetujuan dari Direktur Jenderal Perhubungan Darat atas nama Menteri terhadap kelengkapan persyaratan yang kami keluarkan untuk membentuk menjadikan bengkel umum konversi. Next, dari ini requirement untuk kendaraan motor listrik tadi ada beberapa hal yang menjadi persyaratan. Pertama terkait dengan tenaga teknisi untuk perawatannya, yang kedua juga untuk teknisi untuk instalator, maintenance dan instalator. Yang kedua mereka membuat special tools untuk memasang peralatan listrik tadi. Yang terakhir pasti harus memiliki juga hand tool guna membantu dalam melakukan konversi kendaraan bermotor tadi. Ini beberapa persyaratan yang kami lakukan untuk kendaraan bermotor listrik di Indonesia. Oke. Selanjutnya adalah juga harus memiliki alat uji untuk sentuh listrik, memiliki alat uji hambatan isolasi, memiliki mesin pabrikasi untuk komponen pendukung instalasi, dan memiliki fasilitas keamanan dan keselamatan kerja bagi para petugasnya yang ada di bengkel konversi tadi. Jadi ada pelayanan khusus di dalam bengkel konversi karena ini menyangkut listrik yang cukup kuat, tegangan tinggi dari kendaraan bermotor yang akan dirubah dari kendaraan motor minyak ke kendaraan motor listrik. Next, please. Setelah itu, after that, bengkel konversi itu bertanggung jawab terhadap pengeluaran kendaraan tersebut. They have the responsibility for to have the number license plate. Jadi bengkel konversi yang mengurus surat-surat terhadap kendaraan yang sudah dikonversi oleh mereka untuk melakukan SUT ulang, surut ulang tadi, dan bengkel konversi bertanggung jawab terhadap peredaran dari kendaraan-kendaraan yang mereka bangun tadi, yang mereka rubah menjadi kendaraan listrik berbasis baterai. Oke, ini beberapa hal tadi. Jadi bengkel konversi melakukan bikin permohonan untuk mengajukan bengkel umum. Sudah itu kami akan melakukan evaluasi atas pemenuhan requirement dari yang kami lakukan sebagai konversi. Selanjutnya, kalau memang mereka lulus, mereka akan mendapatkan sertifikat sebagai bengkel umum yang dinyatakan sebagai bengkel konversi. Oke. Ini nantinya kami memberikan sertifikat. Ada yang sudah itu, bengkel itu akan bertanggung jawab untuk mengajukan pengujian ulang kendaraan motor tersebut untuk SUT baru sebagai kendaraan bermotor listrik. Oke, nanti sebagaimana saya sampaikan tempat tadi, ada beberapa hal yang kami tambahan uji untuk kendaraan yang telah dirubah from motor ICE ke motor BEV tadi, dari motor bakar menjadi kendaraan motor listrik berbasis baterai. Oke. Ini tadi akan jelaskan bahwa yang dilakukan itu terhadap pemasangan komponen instalasi sistem penggerak motor listrik dan verifikasi pengasaran komponen instalasi sistem penggerak motor listrik yang salah satu yang akan diperiksa pada saat pengajuan SUT baru oleh bengkel konversi. Next, please. This skema untuk pengujian untuk tes fisik kendaraan bermotor yang telah dilakukan konversi. Ada beberapa item yang dilakukan regarding the brake, rem, headlamp, lampu utama, sound, berat kendaraan, akurasi alat penunjuk kecepatan, konstruksi, dan keselamatan prosedural. Ini beberapa yang akan kami lakukan terhadap kendaraan yang dikonversi tadi. Next. Dari sini kita akan mengeluarkan SUT terhadap kendaraan yang lulus konversi. Untuk selanjutnya dengan hasil ini mereka bisa memproses lagi surat tanda kendaraan bermotornya ke pihak kepolisian, atau kalau memang sudah memiliki, maka ini sebagai bukti bahwa kendaraan ini telah berubah dari kendaraan ICE menjadi kendaraan BEV, Battery Electric Vehicle. Oke. Nah, ada some bengkel, some workshop in Indonesia have a certificate for the bengkel umum, like PT Braja Elektrik Motor di Surabaya, Litbang SDM now in Gunung Sindur, Bogor, Jawa Barat, dan PT Spora Teknika di Benua Hilir. Mereka sudah memiliki sertifikat sebagai bengkel umum yang diizinkan untuk sebagai menjadi bengkel konversi. Oke, next. Saat ini kami masih banyak yang permohonan program tersebut, termasuk dari beberapa kampus, university, they need bengkel workshop for the conversion. Ini beberapa contoh kendaraan-kendaraan yang dibangun tadi oleh PT Beraja, kendaraan study, dengan model yang cukup beda. Mereka membangun motor listrik, tapi masih menggunakan mesin yang lama. Artinya mereka hanya menambah tenaga pemutar dari mesin yang ada untuk selanjutnya menggunakan tenaga listrik. Bukan utuh listrik, tapi masih menggunakan mesin lama untuk digerakkan dengan tenaga listrik. Beberapa juga mereka bangun juga merubah dari kendaraan baru, mengganti semua mesinnya dengan sistem elektrifikasi tadi. Next. Nah, kita mencoba memperlihatkan target Indonesia di dalam roadmap, di dalam peta jalan untuk menuju bagaimana kita memenuhi beralih dari kendaraan BEV, dari kendaraan IC menuju BEV. We have program only for the government car and di pusat maupun di daerah. Juga yang kedua untuk public transport. Some public transport we plan to change to the IC bus, like for the bandara, for the airport bus, for the pariwisata, tourism bus, and of course untuk kendaraan antar kota atau provinsi kita siapkan juga untuk menjadi kendaraan yang menjadi kendaraan bus. Ini beberapa target kami, beberapa kendaraan yang akan kami per tahunnya sampai dengan tahun 2030 kita akan mengganti menggunakan kendaraan listrik tadi, kendaraan bahan bakar minyak menjadi kendaraan motor listrik. Cukup berat, cukup besar target yang kami lakukan, dan ini memang kami membutuhkan dukungan dari beberapa kementerian lembaga yang kami sepakati untuk mendukung bagaimana Indonesia segera berlari dari IC ke BEV sampai dengan tahun 2030. Oke, next. Ini dalam untuk percontohannya untuk DKI, Jawa Barat, Bali, sebenarnya ada juga Jawa Timur dan beberapa KSPN daerah wisata yang kami targetkan juga semuanya akan menggunakan kendaraan listrik berbasis baterai. Beberapa targetnya. Jakarta menargetkan mulai tahun 2025 semua kendaraan angkutan umum Jakarta akan menggunakan kendaraan listrik berbasis baterai. Saat ini secara bertahap, the change from IC to BEV for the public transport in Jakarta. Next. Ini juga roadmap kami, target implementation for the public mass public transport untuk yang berbasis listrik berbasis baterai. Kita coba dengan konsep yang we call the mobile TS, by the service. Mean government pay the operational cost bus for the passenger. Jadi kita menargetkan tahun ini ada 2 kota, Bandung dan Surabaya, dan masing-masing di Bandung 1 koridor dan Surabaya 2 koridor. Pada tahun depan kita mencoba untuk menambah 6 kota percontohan. Selanjutnya kita terus meningkat per tahunnya untuk nantinya pada target berikutnya semua kendaraan target dengan 90% tadi semua angkutan umum massal yang ada di 34 provinsi Indonesia, they will use electric bus. Okay. Is a sample for Jakarta. They have a program to change from IC to BEV for the public transport, mass public transport di Jakarta. Mereka menargetkan mulai 2025 sebenarnya semua kendaraan public transportnya will use the BEV. Okay. Okay, this figure for the Transjakarta. Okay. This target for the tourism area bus in plan Bali Baru, we call Bali Baru, for kawasan strategi pariwisata nasional. This is we plan all the tourism area will use the electric vehicle. Oke, Bapak sekalian, ini lanjut. Nah, ini rencana SPKLU atau Charging Station di Indonesia. This program from PLN and ISDM. Mereka merencanakan untuk membangun beberapa SPKLU mendukung apa yang telah kami siapkan tadi untuk beralih dari kendaraan IC ke BIF tadi. Dan PLN sudah menargetkan tahun ini ada 540 yang akan dibangun, di Jakarta sebanyak 122 yang akan dibangun. Kita menunggu hasilnya di 2021 ini. Yang jelas beberapa untuk lokasi-lokasi percontohan, lokasi pariwisata, PLN sudah menyiapkan untuk dibangun SPKLU yang pastinya source-nya pun juga tidak memanfaatkan fosil tapi menggunakan energi yang ramah lingkungan, like wind, water, ataupun solar cell. Jadi untuk mendukung kendaraan listrik berbasis baterai, source-nya pun dalam SPKLU-nya kita menggunakan yang ramah lingkungan. Oke. Nah, ini adalah program berikutnya yang kami siapkan, the next program untuk Indonesia. Kita merencanakan ke depan ini akan menggunakan sistem swap, sistem baterai, yang nantinya untuk sepeda motor khususnya, akan ada beberapa dispenser untuk penyasan atau dari baterai motor tadi. Mereka tinggal plug and play tadi untuk memasang baterai tadi yang ada di supermarket Indonesia. Ini sudah kami siapkan. Untuk itu kami sudah menyiapkan bagaimana menstandarkan baterai-baterai sepeda motor hingga pada saat melakukan sistem swap ini semua kendaraan sepeda motor yang berada di Indonesia bisa dengan mudah melakukan mengganti aki-akinya baterainya untuk melanjutkan perjalanan. Oke. Ini sudah kami jelaskan tadi. We can next. Lagi. Okay, next. There is our program. Okay, that's all, Pak Bagus. Thank you.
Thank you very, very much indeed, Pak Rizal Wasal. It's been very eye-opening. We have just gotten the snapshots of the readiness of Indonesian regulatory frameworks in expediting the EV uptake. We have heard from you regarding regulations on conversion workshops, the e-bus implementation and roadmap, charging station roadmap. These are challenging tasks to fulfill in order to expedite the uptake of electric vehicle. Before we move on further, I would like to thank again the UK government who had provided funding for the University of Nottingham through the Global Challenge Research Fund, the GCRF funding, that enables our academics to help a range of Indonesian government at municipal and at central level to come up to make provision for this regulatory frameworks. And we would like to remind you again that for those participants who want to ask questions, you can either put your questions in a chat box here, or for those watching in YouTube, you could also do exactly the same there. I would like to also acknowledge the support from Nagara Science Ecosystem, a joint venture between the University of Nottingham and Indonesia, who will support the research and development of EV infrastructure. Now, we have heard from the Ministry of Transportation about these important points. Now, what we will hear from is Professor Satrio Brojonegoro, who is the Indonesian chairman of National EV Acceleration Program. So this is a very important update from also partly the central government about the roadmap by which we expedite the EV uptake. So Professor Satrio Brojonegoro is also the president of Indonesian Academy of Science. And Professor Satrio, can you hear me?
Yes. Yes, I can.
Thank you very much. And after this, I have to switch my background image because it seems to be mirrored. Professor Satrio, good to have you again here. You have been with us for many, many times, and I really cannot thank you enough for your continual support. So we welcome you to share your screen if you can, or if not, then the official will help. Thank you, please.
Okay, thank you, Pak Bagus, Excellencies, dear colleagues, experts, participants, ladies and gentlemen, let me share some of the information I would like to share with you in this occasion. The title is the Indonesia E-Mobility Future. And I'm again would like to remind ourselves the vision of Indonesia in developing the e-mobility. There are three key issues to be fulfilled when we develop the e-mobility. One of the issue is about the environment, of course. Everybody is concerning about the pollution that has been creating the climate change, of course, and the target of the greenhouse gas emission from fossil fuel and transportation is currently about 127,881 gigagrams CO2. This concerns is one of the issue why I mentioned this topic this afternoon or this morning, depending on where we are, because the most pollution or the most greenhouse gas emission is created from the transportation using the fossil fuel. That's why the e-mobility is quite important in order to significantly reduce the greenhouse gas emission into the atmosphere. The second issue, again, I mentioned, maybe Pak Bagus has seen this earlier, that we want to reduce the dependency on imported fossil fuel. Currently, we imported about 800,000 barrels per day fossil fuel, and this create current account deficit in Indonesia fiscal balance. So not only for the environment, but we also want to have some independency on energy, not to depend too much on the imported fossil fuel or energy. The third issue I would like to mention here is the aspect of the industrial resilience. Indonesia not only try to have the cleaner environment, independency for the energy, but also play a major role in global supply chain, especially for battery electric vehicle. So industrial resilience is one of the Indonesia key target want to be achieved. Why is it important? Because Indonesia someday has to be able to perform as an industrial country. And one of the opportunity for Indonesia to come up with the strong industry is in the battery electric vehicle industry. So we have all the potential, we have the technology, we have all this network, and we have also the market. Okay, many of you perhaps understand that the growth of the electric vehicle is gradually increasing. As you can see from the report published by Boston Consulting Group in 2020, these figures show the global car sales through 2030 by the type of the powertrain. And you can see for the electric vehicle, the BEV is one of the strong candidate for Indonesia to develop the electric vehicle. Of course, there are other electric vehicles available, like a plug-in hybrid and full hybrid electric vehicle and mild hybrid electric. But Indonesia is keen on developing the battery electric vehicle, and you can see the population of it is increasing from time to time. By 2030, BEV will occupy about 18% of population, while the rest is can be seen in the figure. Currently, in 2021, only 3% of the BEV and 18% in 2030, the predicted. Why BEV? BEV has some significant benefit for Indonesia to develop. If Indonesia want to develop like the plug-in hybrid, the full hybrid, and etc., we don't have yet the technology, so we cannot catch up with the development of our partners abroad that has been in hybrid technology long time ago. So Indonesia is focusing on the battery electric vehicle of BEV because we have the opportunity to develop this BEV. As you can see from the previous presenter, Parizal, he showed a lot of the activity in conversion workshop that can be done for BEV. That's why BEV is our what I call champion for Indonesia to develop for the future. Another data shown by Deloitte in 2020 more or less give the same trends of development of the EV. There are several categories of EV. There are global BEV and global PHEV, and the EV share and the green light line, you can see this. So maybe 2030, about 30%, 35% of EV share, combining of PHEV and BEV. So the growth is rather moderate, while the agreement, the Paris Agreement in 2015, I think they would like to have this net zero emission in the world or in some country by 2050 or 2045 or 2060. But looking at the figure, I think many things has to be done in order to be able to decrease the zero emission to become net zero in 2050, for example. Okay, in Indonesia, this data just give you the snapshot of the predicted EV market demand in Indonesia. I mean the BEV, the battery electric vehicle demand. While the data shown by Pak Rizal earlier is showing the detailed plan by the Ministry of Transportation. So maybe my data and his data will complement each other. So we can see the predicted market demand for four-wheel EV. 2021 more or less about 5,000, yeah. And then 2025 predicted for about 30,000. And then 2030 already around 120,000 compared to the total demand of the four-wheel. Yeah, mostly still ICE, the combustion engine. So you can see still a small portion for the EV demand currently due to the starting of the technology to develop and to produce PEV. Also talking about charging station. Why charging station? Because charging station is one of the important instruments, infrastructure for the EV. Yeah. So at the same time, government of Indonesia, along with the private sector and the state-owned enterprise, would like to develop the charging station, and we can see the predicted growth of charging station per year. You can see in 2021 about 390 units. 2023, 1,030 units, and 2025 about 2,000 units. Just per year, and cumulatively you can see the number like this. Again, this is the predicted charging station growth in comparison with the demand or the growth of the EV demand, or BEV demand. Okay, this just to give you some highlights. What are the planning for Indonesia in developing BEV? Again, if we want to develop the EV mobility or e-mobility, we have also to see the population of the EV or the BEV. So according to the current survey, there are at least 4 provinces that are potentially high for development or growth of the BEV, including the charging station, of course. So you can see in Jakarta, for example, the percentage of charging station about 39%, so a majority compared to other regions. West Java about 26% charging station to be developed. East Java 9%, and Bali about 2%. In Bali, it will be interesting because we try to use or to make Bali as a green island. So hopefully Bali will come up with the program that it will become the full e-mobility in Bali. Yeah, no more ICE in Bali in the future. That's why Bali is listed one of the province for potential charging station. Okay, the other thing I want to share with you is the National E-Mobility Plan for Urban Transportation. Why this is important? Because as you can see in the beginning, that the majority of the polluter or the greenhouse gas emission is mostly emitted by the transportation, especially public transportation. So if we can do something on the urban transportation, for example, by converting the buses into electric bus, then we can significantly reduce the greenhouse gas emission by due to transportation. For that purpose, some study has been done by my colleague in the Ministry of Transportation. I just pick up the data just to give you some highlights. There are several cities expected to have a significant contribution to the reduction of the greenhouse gas emission. Ya, Jakarta, Bandung, West Java, Bekasi, West Java, Bogor, West Java, Surabaya, East Java, dan Pasar, Bali. Why we select this city? Because we look at the population of the city, and then the classification of the city itself. Classification will determine what kind of mobility will occur or will happen in that city. Yeah, we are core city, metropolitan city, big city, core city, and province capital. And then we are talking about the urban transportation, especially buses. So there are the corridors that has to be determined. Yeah, and each of city, how many main corridors? It will determine the movement of the buses that will affect or influence the greenhouse gas emission. And if you can convert into EV bus or e-bus, then we can solve this problem. Because the corridor is also important for the path of the journey of the EV or the e-bus. And the length of corridor also is also important. Yeah, and that's why we select the city, because those cities have a rather long average corridor. And then from there, they make the electrification target. How many e-bus will be developed or converted from the current ICE bus? So this number hopefully will create a significant contribution to the reduction of this greenhouse gas emission at least in those cities. Okay, dear colleague participants and friends, I would like to also mention why Indonesia is keen on developing the industrial resilience in battery electric vehicle. We want to develop battery electric vehicle because we have the facilities, we have the technology, we have the materials, and we have the market as well, domestically. As you can see, Indonesia have the material resources for EV, for BEV, right, on the left-hand side. And from this material, we create added value to develop EV battery, EV motor and inverter, EV lightweight structure and assembly, and also renewable energy for electric charging station. Right, you can see that the charging station will be using the photovoltaic or the concentrated solar panel, as well as wind turbine. So we create green energy ecosystem in Indonesia. Yeah, because the material produced by our resources, and this component create the EV technology. And for charging station, we no longer use the coal or the fossil diesel or fuel for the power plant, but we're using the green energy or renewable energy. So our vision is an integrated ecosystem linking Indonesia rich material resources to high value EV products through R&D and investment in advanced material and manufacturing technologies, boosting Indonesia's future global outlook, assisted by its comprehensive green energy strategy. So we have the ecosystem like this, which is one of the Indonesia special added value. My last slide, just again to mention to you the importance of the development of aspect of technology in Indonesia for building for green energy strategy, we build integrated ecosystem of material, product, and energy technology. So this aspect, again, we want to develop global leadership, active role of Indonesia across international supply chains. At the same time, we have the local energy ownership, supporting villages and islands to build self-sustainable energy ecosystem, because we have so many islands located in the remote areas, and they need what we call local energy ownership. They cannot depend on the grid because their location is far away from the power plant. Again, we have the material, we have the technology to develop the EV, structure, motor, battery, even charging station. And charging station, we use the wind turbine, photovoltaic, and concentrated solar panel. So again, this is the green energy strategy. Okay, this is something I want to share with you, and hopefully Pak Bagus and the team and Politeknik of Keselamatan Transportasi can come up with a strong concept of having the safer electric vehicle in order to create Indonesia with clean energy, independent of energy, and player in the global supply chain. So thank you, Pak Bagus.
Thank you very much indeed, Professor Satrio. What an insightful presentation, to be honest, because you highlighted the huge demand for EV, and I'm very encouraged by my country's progressive initiative, and that is to expedite the uptake for EV. We heard that we will have projected 1,280,000 demand for EV, along with its peripheral technologies like batteries, charging station. This presents both challenges but also opportunities, especially for academics and industries elsewhere in the world, including in the UK, to collaborate with Indonesian stakeholders to develop technologies needed to make this possible. The battery, the charging stations, the smart grid infrastructures, and others. Indonesia has both the market and the base mineral for batteries. What we need is more collaborations like this. I'm not representing only academics at the University of Nottingham, but also overall diaspora academics spread across the universities in the UK to come together with some solid plan. And for this, we need collaboration from government, academia, and industries. And a perfect transition to also to the next speaker of ours from the presentations by government or representatives. Now we will have academics talking a little bit about what would be needed to support in terms of technology and challenges to support the EV uptake in Indonesia. Professor Pat Wheeler is with us today. Professor Pat Wheeler is the head of research group at the University of Nottingham. Professor Pat Wheeler will talk a little bit about the technologies of EV, particularly from the perspective of the UK and the challenges therein. So to Professor Pat Wheeler, and I was informed that there is a buffer video. Please. Thank you very much. That's beautiful. Professor Pat Wheeler. Pat, can you hear me? I think you're still muted.
Yeah, hopefully I'm not muted now. Can you hear me okay?
Yes, loud and clear. Thank you very much. Your presentation is also up, so time is yours. Thank you.
Excellent. Good. Right, thank you very much for the introduction. I've been asked to talk a little bit about electric vehicles, safety, roadworthiness, and so on. This is something I first got into actually from race vehicles. We started racing electric motorbikes back in 2009. And before that, we did quite a lot of work looking at how you wrote the rules so that you could race safely. not necessarily for the rider, but for all the people involved in that process. So the work I'm talking about comes from our work at the University of Nottingham in the Power Electronics Machines and Control Research Group. We've got a large research group in Nottingham working a lot on renewable energy and transportation electrification problems. We've got a lot of core technologies in electrical machines, power electronic systems, motor drives, and power electronic integration, as well as thermal management. So all the things you need to put a drivetrain together in the type of electric vehicles we're talking about. And that's something we do a lot of research on. When we start to look at roadworthiness for electric vehicles and vehicle safety, it's quite interesting in that you find that most of the roadworthiness tests that you need to focus on are for things like braking systems, lighting systems, structural integrity. Often we look at emissions, driver vision, general state of repair, and that none of these are specific to electric vehicles. Sometimes we have to start thinking about different ways of looking at these topics and maybe looking at them in a slightly different way to the way we traditionally have. But generally, electric vehicles are a simpler machine. The engine and the transmission, so the electric motor, the power electronics, if that fails in an electric vehicle, it doesn't matter. It's a bit like your engine having a problem in your car. It's not necessarily a safety issue. It might be frustrating as a user, but it's not affecting the safety of that vehicle. Some of the other advantages of the electric vehicles when it comes to roadworthiness is there's no emissions to test, that there's no exhaust from the vehicle and so on. So a lot of the safety tests that we do today on a traditional vehicle can be applied to an electric vehicle. Will it stop? Do the lights work? Is the general condition of that vehicle appropriate for use on that road network? So we should be looking for electric vehicles to pass very similar tests, but for it to be just that little bit simpler in terms of some of the things that we currently have to test for, like emissions, are no longer relevant. So starting with now, the next thing to consider in this is the safety of electric vehicles. One of the things you always have to consider with any vehicle is the stored energy that you have. Now, in a conventional internal combustion engine vehicle, this is the tank of gasoline or petrol that you would have there. Your stored energy on an electric vehicle is in a battery. And it comes with some similar but slightly different safety concerns. Petrol does burn. We can see that when you have a vehicle fire. And batteries do burn. The fires are usually caused by a malfunction in the battery system or in damage to the battery system. So one of the things we need to do with an electric vehicle is to make sure that we have a good battery management system, that there's something monitoring the state and health of that battery on the vehicle. And this is something you typically design into the batteries that are used on electric vehicles. And they make sure things aren't getting too hot, that voltages aren't going too low or too high on individual cells, and that the general state of health of that battery is good when it's being used. And if things do start getting too hot, obviously you can shut down that system. You can get fires in batteries if they do get too hot, and they are difficult to extinguish. A fire in a lithium ion-based battery has to be cooled to extinguish it. It can't be smothered because the oxygen is coming from inside the battery itself. So you have to think a little bit about firefighting if you have a vehicle that's involved in a considerable accident and there's damage to that battery which leads to a fire. One of the other things you'll find with electric vehicles is there's usually a way to disconnect the battery from the rest of the system on the outside of the vehicle in event of a fire. And the final fail-safe one there, it will be a place on the vehicle where you can cut through part of the system to disconnect the battery from the rest of the system. But normally some breaker or fusing will have sorted that out before you get to that position. So there's a number of things you have to consider here. You do have stored energy. That stored energy can result in fire, just like a tank of fuel. And you do have to make sure that the battery encapsulation and the battery management system are functional and are taking on that role of protecting the vehicle. Now, obviously, with electric vehicles, we're looking at higher voltages, we're looking at DC voltages, and the whole system we're using is significantly different to a petrol engined vehicle. There's far fewer moving parts. There's no sump full of oil. So actually the servicing requirements are lower than they are for petrol vehicles. So over time, we will need fewer repair garages. A simpler system requires less servicing, requires less repair, and the repairs are more likely to be replacing part of the system, but there's fewer components to replace. Things like brakes, tires, accident damage will continue just as they are at the moment. But repairing the engine itself, rebuilding engines, and servicing engines won't be needed. So there's a change in the skill and the workforce that you need there, and a change in the risks that they will see. Systems are going to be found more by computer diagnosis rather than a mechanic with his looking into an engine bay. But when they do go into that engine bay, the risks are different. We need to start thinking about training that workforce on the electrical shock risk, making sure that they have the right procedures and processes to protect that workforce when they're working on these systems. It's not all bad news for the workforce. There's significant other jobs that are created from the infrastructure needs of electric vehicles. We're going to need to enhance the electrical network infrastructure of countries where there's going to be significant uptake of electric vehicles. These vehicles are going to need charging stations, we should need installing, need maintaining, and need designing initially. So there's a big need for electric vehicle infrastructure, for battery manufacture, and for both the manufacture and also the maintenance of the drivetrains. So to make this safe, you need a workforce that understands these needs, that understands the risks in working in these systems, understands how to design these systems and how to implement them. So there's a big shift in the way in which we need to think about the automotive industry and the support industries for that automotive industry, as well as in creating the new infrastructure that enables the vehicle charging and people to go about their travels in the way that they wish to, and that as a country is good for us. We're just beginning to see the first all-electric service stations in the UK. You can see the first one which is being built down in Essex there, and that particular company are planning to roll out 100 more. It's not enough. We actually need more than they're planning at the moment in order to get the right level of availability of those charging stations, and to avoid people charging vehicles in unsafe ways. You don't want cables across streets and pavements and car parks to connect into a standard building socket. If we can avoid that, we need to make sure the infrastructure is there so that people operating electric vehicles do so in a safe way. I noticed that one of my previous speakers was mentioning buses and urban transport systems, and this is certainly something that we're seeing in many cities in the UK. The example I've used here is London. Nice red buses that are either, all the new buses coming in are either hybrid electric or now moving to full electric. And different technologies are being tried there, including inductive charging, so contactless charging of the buses whilst they're waiting at bus stops, and using things like hydrogen fuel cells as the energy source. So in conclusion, electric vehicles do have a higher purchase cost, they do have lower running costs, and they are zero emissions at the point of use. And the advantages of that have been dealt with by the previous speakers. Safety testing, general safety testing of the vehicle for roadworthiness is broadly similar to existing vehicles, but new skills in electrical engineering and computing are needed for maintaining the vehicles and the infrastructure, and many of the existing car maintenance tasks that we've been doing for many decades are no longer needed. So there's a change, a shift in the skill set that our workforce will need in order to be able to maintain cars in a safe way. So I believe I was given 10 minutes, and I hope that was 10 minutes. Thank you very much for listening, and back to you, Bagus.
Thank you very much indeed, Pat. Thank you very much. So Professor Pat Wheeler had highlighted some of the key elements that need to be paid attention to when you want to ensure safe electric vehicles. And also there's interesting aspect in that presentation is that the human resources need to be upskilled too. And that's challenges not only unique to Indonesia, but also for the UK. There's a room for collaboration at the academic level in order to support that and to make that sustainable in Indonesia. On to the next speaker, Dr. Tony Parry. Dr. Tony Parry is also an academic at the University of Nottingham, associate professor at the Nottingham Transportation Engineering Center, who will tackle on a very different aspect of safety, more on the road transportation, on the road infrastructures, because it has bearing when you implement EV into the readiness of your road infrastructures and structural integrity. So, Tony, can you hear me?
Yes, I can hear you. I'm going
yes,
to...
apologies for the buffer video, please. I love it.
Thank you. I'm going to...
thank you very much. Yeah. Can you...
try and share my screen.
Thank you.
I hope you can see that. So my name is Tony Parry, and good morning to everyone in England, and good afternoon to those in Indonesia and around the world. Hello, thank you for coming to talk to us. So as Bagus said, I work in the Nottingham Transportation Engineering Centre, where we research the road materials design and construction. And I need to, in the spirit of collaboration, I need to acknowledge Fadzanella Sawatu, who is an Indonesian PhD student in the centre, in the research centre. She has been helping me by reviewing and telling me something about Indonesian road building standards, although her PhD is on carbon footprinting of roads. So I will just say we should remember that if we're successful in decarbonising the vehicles, the largest carbon footprint from road transport will actually be in the construction materials and in the construction processes. But that's a different message, because today we're here to talk about safety. It's a well-rehearsed statement in road safety fields that road safety is a combination of many factors, including the driver, the vehicle, and the condition of the road. So I'm going to be asking, what can the road pavement engineer do to improve road safety? And I'm going to show you the results of some of our research over recent years that I hope can help to answer that question by looking at three things. Firstly, the condition of the road surface, because that's the part of the road which is almost continuously being monitored and, when necessary, maintained. So that's the part the pavement engineer can really influence frequently. In particular, the skidding resistance of the road surface. And then I'll be looking a bit at how to provide that skidding resistance by choosing the crushed rock or other aggregates we use for road building. And then returning to the vehicle, I'll be saying something about how we might exploit the sensors which are on modern vehicles to tell us something more about the road on which those vehicles are driving. So without further ado, and I hope you can see my mouse, I think the first thing I want to tell you is that if we look at numbers of road accidents on roads, they don't happen entirely at random. So for instance, here's the number of accidents on road segments against the radius of curvature of those segments. And what you can see, and may not be any surprise, is that below a certain radius of curvature, accident rates increase. And the same is true if you look at the distance from junctions. As you get closer and closer to junctions, the number of accidents increase. So that tells me that when we think about road safety and surface condition, we should be looking at different parts of the road network differently. Now here, I'm looking particularly at bends, the total accident rate, the dry accident rate, and the wet accident rate on bends. And here we've got the number of segments in the green bars plotted against the skidding resistance of those road segments. And what you can see is that as the skidding resistance falls, the number of accidents markedly increases, both in the wet, which you might expect because that's when the skidding resistance is lowest, but also in the dry. So it makes sense to improve the skidding resistance of your road surface and maintain it above a certain level. And Fardinella tells me that there is a skidding resistance standard in Indonesia, but that it applies only to highways and high-speed roads. And it's set at one level. So when this is under review, I would strongly recommend that you look at the statistical relationships between numbers of accidents for different types of roads, roads with gradients or bends or on the approaches to junctions, the relationship between skidding resistance and accident rate broken down by different types of road geometry. We've done that in some research. If you're particularly interested, you can find the PhD thesis at this web address. And what I want to show you here is the change in accident frequency, the reduction in accident frequency that we modeled to occur for dry accidents, the green boxes, and wet accidents for different road categories. For the whole road networks, and where there are what we call non-event sections, that's to say regular driving, no junctions, no gradients, no bends. And you can see that as the skidding resistance increases, we've chosen 10% increase here, the dry and wet accident rate fall. But look how that increases, particularly in the wet, for bends below a certain radius. So it's worth looking at different geometry of road sections differently. Here, we've got the reduction in accidents for a 10% increase in skidding resistance, broken down not by wet and dry, but whether or not there was a slight injury in the accident, or there was a very serious or fatal injury in the accident. And again, you can see that for certain geometries of roads, you get very different patterns compared to the network as a whole. So in the UK, work like this has led to quite sophisticated skidding resistance standards, very detailed skidding resistance standards, where the road network is broken down into different categories. Motorways, non-event carriageways, with one-way traffic, and then what we call single carriageways, traditionally two-way traffic, and then approaches to junctions, roundabouts, gradients, and bends. And the required skidding resistance level, based on these accident studies, increases for these different roads. We've got low-risk roads here, LR, and then standard roads here. And if you want to find out more about those standards, you can look them up online. So we want different levels of skidding resistance for different types of roads. But how are we going to provide that skidding resistance? Now, we build our roads traditionally out of crushed rock on the road surface, held together either with cement or bitumen. And those rocks will polish under the action of traffic. And what's more, where we want the skidding resistance to be highest, they probably polish more because they're where the braking and turning happens. And you can see that, two examples here, certain aggregates of certain geologies don't polish very much under traffic, whereas others polish quite a lot. And you can imagine, particularly in the wet, that this polished aggregate is very slippery, whereas this one maintains a certain amount of grip. And again, Fardinella tells me that you, when you build roads, you measure the abrasion resistance of your materials, which we do also in the UK. But in addition, in the UK, we measure the polishing resistance to try and specify the right polish resistant aggregates in the right places. And again, in our design standards, you can see how we specify the polishing resistance of the aggregates to be put in roads. And I believe that the adoption of the polished stone value test that we use for setting these values is under consideration for adoption in Indonesia. Thirdly and lastly, I just want to briefly mention, as I said at the beginning, how we can use outputs from vehicle sensors to tell us something about the condition of roads. And you all know that modern vehicles, and hence electric vehicles, all of which are relatively modern, are packed full of sensors. And we've been looking particularly at how the accelerometer data from sensors in cars or trucks can tell us something about the condition of roads. On the right-hand side here, we've got a small urban road network with different defects, patches or sunken drains, cracking potholes, and where they are. And very simply, if you measure accelerations in vehicles and process them in the right way, you can find the details of this paper. You can see that where we predict from the accelerations minor and major defects to have occurred corresponds very closely to where they actually exist. And lastly, here we have the 10-year injury accident record at a particularly busy motorway junction in the UK, not very far north of Nottingham, actually. And you can see these accidents where they happened at this grade separated junction, largely on the approaches to the roundabout and on the roundabout itself. And there is a company close to Nottingham that measures for truck fleet operators where the drivers have undertaken very harsh braking maneuvers, again from accelerations measured in the vehicle. And for 2 years of accident, 2 years, you can see where these incidents are. Two things I want to observe. Firstly, they're at more or less the same places as the accidents. And secondly, there are very, very many more of them. And that means that for the type of statistical analysis I've been describing, you get a much larger database and therefore a much more reliable statistical analysis. The question is, can these accidents, these accelerations, these harsh braking decelerations, perhaps I should say, tell us something about accident risk? Well, if you analyze those accidents and those incidents in exactly the same way, what you find is that you get very, very similar relationships between the rates of accidents or harsh braking and the geometrical and traffic characteristics of motorway roundabouts. We chose 70 to analyze, and you can see the results in this paper. I'm just going to skip the next slide and finish, because I think I've probably spoken for too long already, and just conclude that when you're thinking about the safety of electric vehicles, I would recommend that you think beyond the vehicle itself, and also think about the road infrastructure as well, which is an area of academic collaboration which I'm sure we can develop. Thank you for listening.
Thank you very much, Tony. Thank you very much indeed. Here's why it's important. So safety is a very important aspect in developing any technologies, including EV. It was mentioned there in the presentation by Tony, for example, the role of braking incidents, harsh braking incidents. There are many different parts that divides between combustion engine cars and EV. So we have the terms regenerative braking in EV, for example. This is something that has to be looked upon from many different angles. And there are many technological challenges, not least that the industries are facing. So our next speakers, the two speakers, will give us insights from the industries. And I'm very happy to be joined by a very senior figure in Hyundai, the Vice President and Chief Operating Officers of Hyundai Motors Asia Pacific, Mr. Lee Kang-hyun, who are with us today. So I would like to introduce Mr. Lee. Maybe the buffer video can chip in now. Mr. Lee, thank you very much for being with us, and thank you for waiting until your turn. So if you can hear me, you're welcome to share your screen.
Okay, thank you very much for this invitation. And actually, who will be showing the presentation data? You not prepared from your side?
If you have given it to the officials.
I know from your side the prepared. I'll try from my computer. Wait a second. Yeah?
Sure.
Yes, I'm so sorry. Suddenly. Sorry.
That is absolutely fine. Do not worry. We will wait.
Let me check first. Yeah. Okay.
Perhaps from PKTJ, if you have it online, perhaps you could have it sent. I actually got sent something by now, so okay, let me try to download this real quick. Mr. Lee, I actually have it open in my computer if you want me to share my screen instead. We'll give a minute. Wonderful, it's working. We can see it now.
Is working?
It is. Thank you.
Okay, okay. Thank you. Thank you very much. Yeah. Sorry. Okay. I'm so sorry. Maybe something wrong with my step. I'm Lee Kang here. Actually, I'm working for the Hyundai Motors.
Apologies, Mr. Lee. Apologies.
Yes.
Do you mind making it full screen, please?
Full screen, actually.
Thank you. So there's that button at the bottom. At the bottom right.
Something.
Yeah, if you hover onto the bottom right, there's that sign which I.
Yeah, because I'm using the two.
I think that's all right then. That's all right. I think it was okay. And if you want to, yeah, present it as it is, it's all right too. We can see it.
Sorry, yeah.
That's okay. And please don't mind if you want to switch between English and Indonesian language as well. I know that you're very fluent in Indonesian. So
yeah, thank you. Yeah. So
whatever
I'm
makes
so
you
sorry
comfortable.
because actually I'm using the two monitors, so maybe I cannot operate with a bigger screen. Sorry, I'm so sorry. Yeah.
That is okay. Thank you.
Yeah. Anyway, I'd like to explain about the Indonesia automotive industry. So first page is actually the Indonesia automotive industry. The pertama, actually, Indonesia we produce it's a whole automotive industry is a 1.29 million, and then total current capacity is 2.4 million. But currently, the Indonesia situation is because of the COVID. So now only just around 300 something sales until June of this year. And actually the present regulation number 55 is actually the government has the targeted to reduce carbon emissions by 29% in year 2030. So we just want to know the real EV demand. Real EV demand is actually very small situation currently. Even this data is actually provided by Departemen Perindustrian. Mereka bicara tahun 2025 sampai mungkin 700.000 unit, and then tahun 2030 bisa sampai mungkin 750.000 unit. Tapi sebenarnya ini just a mimpi lah, it's just a dream ya. Current Indonesia situation ya, until last year total sales EV only the 1,000 unit, including hybrid, not only EV saja. Jadi sebenarnya kami memang melihat, dan actually presented by Mr. Dr. yang Satrio already mentioned, kira-kira tahun 2025 just reach around mungkin 30.000 unit, terus yang kira-kira tahun 2030 bisa sekitar 120.000 unit saja. Tahun depan pun juga, tahun depan atau tahun ini juga sekitar hanya 3 sampai 5.000 unit saja. Jadi ini memang real situation of the Indonesia EV market. Next ya, kita memang bisa bicara mengenai arahan peraturan dari pemerintah bagaimana bisa mendorong mobil listrik. Actually di Indonesia ya, Hyundai udah investasi around maybe 1.5 billion US dollar, and then we will be start produce ICE mobile from end of this year, but next year around March we will be launching new EV model from Indonesia factory directly by the CBU base. Tapi sebenarnya di Indonesia, if the government tidak kasih subsidi, market size-nya memang bisa tambah besar itu sangat sulit. Di negara lain memang ada subsidi dari pemerintah, tapi Indonesia tidak mungkin ada yang subsidi untuk menjual atau meningkatkan mobil listrik. Oleh karena itu, sebenarnya masalah yang paling pentingnya harga mobil listrik. Harga mobil listrik, currently Hyundai memang jual dua mobil, itu namanya Ioniq sama Honda, tapi harganya sekitar 700 juta rupiah. Ya. Dan dari Cina masih belum masuk, terus yang ada brand yang lain-lain itu harganya di atas 1 miliar. Harganya sangat tinggi, jadi mungkin ini hanya high top segment saja mereka bisa membeli mobil listrik. Oleh karena itu, harga mobil itu bagaimana adjust itu mungkin sangat penting di Indonesia. Jadi memang just last month, government announced the PP 74. Ini sebenarnya dan kiri kalau lihat ini PP 73, tapi ini bisa sekarang bisa pindah PP 74. PP 74 ini kita lihat hybrid, misalnya CO2-nya di bawah 100 dari 2%, ini memang bisa naik sampai 6%. Kenapa alasannya? Karena EV-nya memang 0%, tapi kalau hybrid harganya kalau misalnya mendekat sama EV, mungkin konsumernya bisa belanja EV. Tapi kalau hybrid car-nya mendekat harga dengan ICE, pasti transfernya dari ICE ke hybrid, bukan dari ICE langsung ke EV. Oleh karena itu, kita memang perlu adjust price of mobil, ya. Dan sekarang Cina dan India, dunia mereka memang arahnya bukan dari ICE ke hybrid, langsung ke EV. Tapi kalau Indonesia, arahnya dari ICE ke hybrid itu udah terlambat. Dibandingkan sama Thailand pun juga kami memang bisa kalah. Karena itu bagaimana langsung kami memang transfer dari ICE ke EV. Berarti mungkin harga mobil itu jangan yang bisa memberikan keringanan kepada hybrid. Oleh karena itu, first stage-nya hybrid itu memang pajaknya bisa naikin, PPNBM-nya bisa naikin. Dan juga second stage-nya ini, misalnya kalau investment ada yang EV ekosistem itu di atas 5 triliun, ini mungkin bisa harganya lebih jauh dari ICE, jadi dari EV. Oleh karena itu, second stage ini mungkin sekitar tahun 2004 ya, ini mungkin bisa hybrid tax-nya 10 dan 11-12%. Ini memang kebijakan pemerintah biar langsung transfer ke EV. Memang ini tergantung mengikuti TKDN. TKDN memang di bawah ada, tahun 2002 ada harusnya di atas 40%, tahun 2024 di atas 60%, tahun 3000 atas 80%. Ini memang kondisinya. Dan baru kemarin di announcement-nya, LG sama Hyundai udah ada yang satu kelompok maunya investasi battery cell factory di Indonesia. Ini announcement yesterday by Bahril Menteri PKPM. Kira-kira 1,1 miliar US dollar ini investasi dari tahun 2001 sampai tahun 2003 memang membangunkan di daerah Karawang karena mobil Hyundai pabriknya di Cikarang Delta Mas, jadi memang lebih dekat. Jadi di Karawang memang ada membangunkan pabrik battery cell. Ini kira-kira mungkin 10 gigawatt hour ya. Ini mungkin bisa dimanfaatkan untuk mobil listrik Indonesia dan bisa ekspor juga. Jadi dengan kondisi ini mungkin TKDN bisa naikin. Terus next page. Seperti tadi yang saya sudah sebutkan, bagaimana memang kita mendorong mobil listrik di Indonesia. Jadi perlu mungkin support dari government. Yang pertama, yang exemption of the tax. Misalnya BBNKB itu sebenarnya udah ada, harusnya memang dinolkan. Tapi ini dilaksanakan hanya di Jakarta saja. Jadi ini memang nationwide harusnya memang bisa memperluaskan. Jadi biar mungkin masalah pajak bisa memberikan keringanan. Jadi biar mungkin walaupun tanpa subsidi dari pemerintah, tapi memang consumer mereka bisa berbelanja mobil listrik. Terus satu hal lagi itu sangat penting. Yang pertama, sales of the EV itu sangat kecil. Oleh karena itu harusnya ada yang dorongan dari pemerintah. Dorongan dari pemerintah itu sebenarnya pemerintah mereka sendiri kalau ada yang government use mobil itu transfer dari ICE langsung ke mobil listrik. Ini memang dari pemerintah sendiri harusnya melakukan dan mengusahakan kebijakan seperti begitu, pasti mungkin industrinya bisa bangkit. Misalnya itu satu contoh di Amerika, udah itu new president Joe Biden udah mengumumkan harusnya Amerika memang bisa buatkan mobil listrik Amerika sendiri dan juga udah tanda tangan tahun ini 645.000 unit belanja mobil listrik saja dengan buatan mobil listrik Amerika. Ini memang kebijakan sebagai contoh. Jadi di Indonesia juga buatan Indonesia dan secara kuantiti mungkin dari pemerintahan mungkin semuanya kumpulkan, jadi ada anggarannya mungkin tiap mungkin pemerintahan memang lain lagi ceritanya, tapi secara berulang dan secara bertahap harusnya mungkin 1 tahun ini dan tahun depan, terus tahun berikutnya kira-kira berapa kuantitinya harusnya mungkin belanja atas nama pemerintah dulu, jadi akhirnya mungkin dari consumer sendiri bisa mengikuti juga, dan dari supplier dan dari manufacturing juga sesuai quantity base memang bisa investasi ke Indonesia lagi. Ini sangat penting, dan jangan hanya mungkin mengarahkan misalnya PLN atau mungkin pemerintah memasang charging station. Itu walaupun diumumkan di anggaran belum budgeting tidak mungkin dilaksanakan. Jadi yang pertama itu memang harusnya di anggaran dimasukin dulu, ya. Ini sangat penting. Tahun ini juga saya udah checking ya, anggaran charging system tidak ada. Ya walaupun ada COVID, kondisi begini saya mengerti, tapi kalau tidak ada anggaran mana mungkin. Tolong dipertimbangkan hal yang ini. Dan masalah charging system juga di negara lain dengan peraturan pemerintah harusnya memang new building atau shopping center itu semuanya memasang charging system. Tapi di Indonesia dengan peraturan belum ada, jadi ini memang kejadian biaya dan juga shopping center atau apartemen itu bukan urusan saya ini. Mungkin perlu izin dari pemerintah, oleh karena itu mereka I don't care gitu. Kalau itu mana mungkin ini bisa boost up. Itu pun juga harusnya dipertimbangkan oleh pemerintah sampai bisa jadi peraturan pemerintahan bisa ini mungkin harusnya mungkin mestinya harusnya pasang new building seperti begitu. Kebijakan seperti begitu memang kami perlu. Terus yang terakhir saya mau bicara mengenai TKDN ya. Ini TKDN itu sangat penting karena buatan Indonesia. Berarti buatan Indonesia, mobil IC yang biasa saja. Sekarang kita bicara mungkin, wah, local content-nya 60% itu tidak mungkin. Ini hanya second tier and third tier mungkin kalau bisa buat di Indonesia atau sedikit modifikasi bisa kasih angka. Jadi memang kondisi TKDN mobil 60% di atas, tapi tidak mungkin. Kalau hitungan benar-benar itu mungkin hanya 20-30% saja. Jadi memang TKDN itu harusnya juga kita memang mempertimbangkan dengan kondisi sekarang. Mobil biasa pun juga hanya bisa 20-30% TKDN lengkap, tapi anak itu baby, mobil listrik mana mungkin bisa langsung lari. Jadi memang jangan angkanya 40, 50, 60, 80, jangan menganggap gampang. Atau mungkin, oke, angkanya kalau kasih 40, 60, 80%, yang bobotannya harusnya memang dipertimbangkan lagi secara detail. Yang pertama, kita coba lihat co-patch-nya itu, yang paling pentingnya di mobil listrik kira-kira 40% harga itu harga baterai. Berarti baterainya kalau belum ada di Indonesia, mana mungkin ada co-patch-nya bisa dibuat oleh Indonesia. Jadi sampai tahun 2024, misalnya kalau ada MOU atau mungkin sudah dilaksanakan investasi baterai, kasih angka 10 atau 20 atau 30. Jadi biar mungkin tahun 2022 di atas 40% bisa dapat angka dari battery investment, misalnya 10 angka atau 20 angka yang bobotnya biar dapat. Jadi biar mungkin yang dari luar mereka mulai investasi. Terus yang support parts, co-parts yang tanpa battery yang lain-lain juga, saya mengerti arahan pemerintah. Oke, harusnya mungkin pakai buatan Indonesia atau dari Indonesia. Tapi di Indonesia sekarang makinnya di bawah 1000 unit. Mana mungkin ada yang investor? Kalau memang mengenai mobil listrik, kira-kira total makinnya di atas 50.000 unit, mungkin ada investor mulai mengenai parts. Jadi jangan dari pertama pun juga kasih angka untuk mungkin support part atau co-part. Tidak mungkin. Ini mungkin sangat sulit. Market tidak ada, siapa investasi dan juga angkanya dari mana. Jadi ini mungkin tahap pertama dari tahun 2022 sampai tahun 2024 ya. Mungkin ini memang bisa angkanya kecilin. Dan juga memberikan yang ketiga R&D dan assembly. Misalnya R&D itu pun juga desain atau mungkin hak paten itu mana mungkin langsung dari Tesla atau Hyundai kasih ke Indonesia. Nggak mungkin, berarti ini pun juga kalau di Indonesia kerjasama dengan PPTN atau kerjasama dengan mungkin ITB gitu. Jadi mungkin satu udah ada mungkin kasih angka, dan juga mungkin di Indonesia udah mulai kegiatan apa kasih angka. Jadi R&D persentasenya harusnya mungkin kasih duluan. Dan assembly itu juga, kalau pasang di Indonesia kasih angka tinggi. Selanjutnya misalnya tahun 2024 ada yang udah ada investasi udah ada yang gerakan patch-patchnya ada, berarti mungkin assembly point-nya di atas tahun 2024 mungkin diturunin. Jadi mungkin yang perhitungan TKDN pun juga secara kesimpulan dari tahun 2022 sampai tahun 2024 mungkin 40% itu bisa mencapai dengan assembly di Indonesia, dengan percobaan R&D di Indonesia, dan dengan battery investment bisa memberikan angka jadi biar di atas 40% dulu. Terus lanjutnya dari tahun 2026 ada yang tambahan investasi co-part, support part, dan juga battery udah ada di Indonesia, berarti battery pakai dari Indonesia kasih angka, dan juga assembly-nya mungkin bisa turunkan angka, jadi mungkin secara total di atas 60% biar mungkin mencapai. Ini mungkin permintaan dari industri kepada pemerintah. Saya menjelaskan sekian saja. Kalau ada mungkin pertanyaan silakan. Terima kasih banyak.
Thank you very, very much, Mr. Lee. What an insightful presentation, really. For those non-Indonesian speakers, I'd like to just highlight what Mr. Lee emphasized just now. So there is this still concern in relation to the lack of incentive for Indonesia to migrate not directly to EV, but rather to hybrid technologies. And also there's this concern about total domestic content of the product. I would say that some of it could be, indeed, you highlighted the R&D as one of the things, but Indonesia is lacking the technologies to respond to that. And this could be something that the universities in the UK could perhaps help to lower that barrier of entry and reducing the price. You mentioned about the Ionic price being in pound sterling between 35K to 40K. Too expensive. Great insights. Thank you very much. Our next speaker is from, which is really relevant because you mentioned about PLN several times. So our next speaker is the Executive Vice President of State Electric Company. Dr. Zainal Arifin, can you hear my voice clearly?
Yes.
Thank you very much. Mr. Zainal Arifin is our last speaker today. After this, we will move on to question and answer sessions that I have already listed the questions of. Thank you very much, Pak Zainal.
Okay. Yes, good afternoon, everyone in Indonesia, and good morning, everyone in London. Yeah. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to apologize you all that my President Director cannot join this webinar, so that I will deliver the material on behalf of him representing the PLN. Allow me to share our material. Okay, related to the topic of the webinar is about the safer electric vehicle. So I would like to share with you about the EV infrastructure standard and safety. So why infrastructure? Yeah, talking about the EV development in Indonesia, we can start with the legal foundation, the Indonesia Presidential Decree number 55 2019. At the article number 3, the decree is about acceleration program of battery electric vehicle for road transportation. What the content of the presidential decree? At least we will have 5 main issues. Number 1, how we accelerate for developing national BEV industry, how we provide incentive, and then number 3, how we develop EV infrastructure and regulation about the charging for EV. And also number 4 is compliant with the BEV technical requirement, and also the last one is protection of the environment. So following the article number 3, the article number 22 is explain more detail about what kind of the EV infrastructure. Actually, there is two things of the infrastructure. Number 1 is electric vehicle charging station, and number 2 is battery swap facility. Following the article number 22, number 23 is explained that at the first step, the provision of EV infrastructure was conducted through an assignment to PLN as the electricity state-owned company in Indonesia. Indeed, for developing this EV infrastructure, PLN can cooperate with other companies following the law exists in Indonesia. So we already make the roadmap for both EV charging station and also the battery swap. We talk about the EV charging station mostly for the 4-wheeler and battery swap mostly for 2-wheeler electric vehicle. So based on this roadmap we already put the number, how many electric vehicles charging we want to build by year. We have planning actually for the next 10 years. About 30,000 EV charging stations we want to build. Indeed, for developing the infrastructure, PLN doesn't want to do by PLN itself. So we open for everyone. We give opportunity through the partnership for developing this EV infrastructure in Indonesia. So based on this roadmap, actually, For example, in 2020, we develop we would like to develop about 168. The target is delayed because the COVID delay a year later. Yeah, so in this year, so based on the number, actually PLN only want to build about 67 EV charger, and the remaining 101 we offer to the private, to everyone who would like to develop this infrastructure in Indonesia. How about the type of EV charging itself here? We already defined that EV charging in Indonesia consists of 3 types: the slow charging, normal charging, and fast charging. And the ratio of the EV charging will be 50%, 30%, and 20%. 50% is slow charging, 30% is normal charging, and 20 is fast charging. How about the battery swap? Actually, we still intensively discuss about how we choose, how we define the right business model for this battery swap, because the business model of battery swap is based on the best practice is the successful is very limited. Only as our understanding, only Taiwan and a part of China, yeah. If China has been successfully to develop this, but in some countries still not proven well. So we still discuss intensively to define the right business model for developing this battery swap for two-wheeler, actually, with all stakeholders in Indonesia. So talking about the safety, yeah, of course, we should define the standard of the EV charging itself. We all, as I mentioned before, that in Indonesia we define the EV charging consists of 3 levels, 3 types: the slow charging, normal charging, and the fast charging. For example, in the output current, yeah, for the slow charging about 16 AC, and the normal charging about 63 AC, and for the level 3 is 100 AC or 250 DC. And for the output power kilowatt, the level 1 slow charging less than equal to 3.7 kilowatt, level 2 normal charging less than equal to 22 kilowatt, and level 3 is less than equal to 22 kilowatt and 43 kilowatt AC, and also less than equal to 250 kilowatt DC. And also for the plug-in type, we follow the international standard IEC. IEC 62916 series 2 for the type level 1, type 1 and type 2, and the level 2 is IEC 62916 series 2 for type 2, and for the level 3, we follow IEC 62916 series 3, type EE, BB, EE, and FF. The standard has been launched in 2017, 2 years before the presidential decree is published. So if we talk about the EV charging, yeah, basically we will have at least 4 main parts. Is about the plug-in itself, is about the communication, is about the charging topology, and about the safety. All the main main component of EV charging, we comply with the international standard, mostly based on IEC and also ISO. For example, yeah, maybe the most important thing related to this webinar is safety. We know that the EV charging itself located in outdoor, yeah. So we should choose the highest index protection of the EV charging station. It can be survive with the heat rain, with the strong wind, and also with the so many extreme weather outside. So why we choose several IEC with the highest standard of protection, because it should be mostly safety for the EV charging station. We cannot we should avoid for a case, for example, that EV charging station should be still survive because the heavy flooding. For example, in Jakarta, we often get the flooding in several locations. So we should keep the EV charging still safe, even though there is the heavy flooding around the EV charger. This one, the worst case, we already predict. So I put the safety based on the high index protection, based on the IEC and also based on the ISO. So for not only for the standard, but also to ensure the operation in commercial state, the government already published, already issue the Minister of Energy and Mineral Resources number 13 in 2020 is about the mandatory for having the operation license for everyone who want to operate the EV charging in Indonesia. So based on this figure, we can look here that actually the configuration of the charging with the EV consists of the public and private section. So for the red line, this will be regulated by the operation license, should be past the technical criteria for having for ensuring the safety before the commercial operation. Based on the interfacing this between the plug-in with the plug-in of supply electricity, and also with the charging station supply with also the plug-in of the battery of EV. So this for the public, we should pass the regulation. The operator should have we call it SLO, Certificate by Operasi, maybe like operation license and for the private, it will be regulated by other standard, usually product standard of the battery, of the electric vehicle itself. It will have different standard, mostly is product standard. And based on that, so we try to start the developing of EV charging station in Indonesia. Right now, we already built about 24 EV charging station still in main cities, such as Jakarta, Tangerang, Bandung, Semarang, Denpasar in intercity highway. This is still limited. We know about that. The number is still very limited. Instead of PLN, EV charging station showcase, actually right now over 100 EV charging station has been built and operated by private in 32 locations. All the charging should pass the regulation of safety issued by Minister of Energy and Mineral Resources, and also should pass the SPLN standard about the electric vehicle charging itself. Indeed, if talking about the EV charging, we also apply such software, building the platform, because we should connect the charging station between charging station with electric vehicle, and also should give information by real time to the EV owner how they can know which the location, the close location of EV, and how the status is still on use or already off use. That's we call it the platform of electric vehicle. We already developed the such platform of electric vehicle charging station, we call it charge in, and not only regulate the technical thing about the charging itself, but also we should put with the payment system. So why we also for this platform, we refer to the international standard. For example, connection between EV charging station, we use OCPP standard, Open Charge Point Protocol standard. So I think this the last my question. The conclusion, I would like to say that the number one, to ensure the safety of EV charging software, hardware, and security of software or platform, Indonesia EV charging station system has complied to the international standard. And the second one, how about the security of our supply? So the point number two, I would like to say that don't worry about the supply of electricity, because right now electricity market in Indonesia is over capacity. We have over 14,000 megawatt reserve of electricity. We don't use yet, yeah. So even we have the 1 million EV on the road today in Indonesia, so they need only about 2,262 megawatt. Our reserve is so far than enough, so sufficient for that. I think that's all of my presentation. Thanks for your attention. Back to the moderator.
Thank you very much, Pak Zainal. Thank you very much indeed. Great to hear the insight from PLN, from State Electric Company. So we are at the end of our event today. I've got some questions in front of me, one for each. And without further ado, I'm going to ask the first question directed to Pak Muhammad Rizal Wasal. The question is from Edi Gunawan, Kapus Litbang Jakarta. Pertanyaannya, according to the Perpres that the kendaraan angkutan umum or public transportation will occupy 25%. That 25% will use EV. We got challenges. Sejauh mana kesiapan pemerintah untuk pelaksanaan uji berkala terhadap kendaraan angkutan umum listrik tersebut? Banyak dihadapi kendala dalam pelaksanaan oleh 514 kabupaten kota di seluruh Indonesia. Bagaimana kesiapannya, Pak Rizal Wasal?
Baik, terima kasih Pak Bagus. Thank you Pak Edi. Ada beberapa pertanyaan saya baca di chat. We have many question in the chat Pak ya. But before I answer the Pak Edi question, maybe we need to explain about what Pak Lee talked before regarding our concept. Boleh Pak Bagus ya sebentar ya?
Ya, sure Pak.
Oke, Pak Bagus, Pak Lee. Pertama terkait dengan dari kendaraan IC to BEV, that's Indonesian policy, kebijakan Indonesia bagaimana kita ngejam dari kendaraan listrik kepada kendaraan listrik. Kami bicara kepada transportasi yang ramah lingkungan, berupaya untuk mengarah sana, bicara tadi. Bukannya kami Pak juga tadi agak worry kalau kita bicara kendaraan hybrid. Pada prinsipnya kami bicara ke lingkungan. Kalau hybrid bisa bicara tenaga fosil, bahan bakar fosil, maka kami ngejam langsung ke electric vehicle yang berupaya untuk tidak menggunakan fosil. Satu itu, dan kami pun sedang menyiapkan juga untuk mendukung kendaraan listrik ini, SPKL-nya pun pada kawasan tertentu, kawasan wisata dan kawasan lainnya itu yang tadi saya sampaikan menggunakan bahan yang ramah lingkungan, bisa dengan solar cell, bisa dengan bio ataupun dengan tenaga air yang bisa untuk menyuplai listrik pada SPKL tadi. Pertama itu Pak Ali kebijakan. Yang kedua yang kami sampaikan tadi adalah baru terhadap kebutuhan terhadap kendaraan operasional perkantoran baik di pusat maupun di daerah. Yang kedua, kendaraan angkutan umum, baik itu pariwisata, perkotaan, maupun bandara. Yang ketiga, sepeda motor dan bus untuk pelayanan transportasi perkotaan. Itu kita baru bicara sampai sana. Terhadap TKDN, Pak Ali, kami tidak hanya bicara tentang mobil kendaraan seperti Hyundai. Kalau Pak Ali tadi lihat daftar saya, dari 50 SUT, sudah ada kendaraan yang beredar itu lebih daripada 1.000. Dari 43 SUT kendaraan roda 4 sudah 2012 kendaraan yang punya surut. Artinya Pak Ali bisa berkaca di situ bahwa sudah ada 2012 kendaraan listrik yang ada di Indonesia yang memiliki surutnya dengan berbagai merek. Saya nggak nyebutin merek kendaraan Bapak, tapi berbagai merek sudah ada 2012 yang memiliki surut, yang kami keluarkan surutnya dari 43 merek atau 43 surut. Sementara sepeda motornya Pak dari 50 itu ada 5.400. Dan sepeda motor inilah yang sangat dimungkinkan sekali TKDN-nya 60 bahkan melebihi dari 60 persentase TKDN-nya. Jadi bicara TKDN, not only bicara kendaraan yang bagus, tapi kita juga bicara kendaraan sepeda motor, bahkan kendaraan untuk angkutan barang, untuk angkutan petani, dan kendaraan roda 3. Dan ini lebih banget memungkinkan untuk dibuat TKDN yang lebih daripada 60%. Don't worry Pak Ali, pasar ini mempunyai market masing-masing terhadap kondisi itu, Hyundai punya market dan lain-lain punya market. Kami tetap pede, tetap yakin apa yang kami siapkan konsepnya untuk mendukung daerah kawasan pariwisata nasional, mendukung angkutan perkotaan, mendukung program kami dalam by the service untuk angkutan-angkutan umum yang ada di wilayah Indonesia. Kami punya target-target, punya beberapa sampel-sampel, punya beberapa percontoh-contohan untuk melaksanakan itu, untuk melaksanakan roadmap atau peta jalan yang kami susun di dalam beralihnya dari kendaraan berbahan motor terhadap kendaraan IC. Yang kedua terhadap Pak Edi, bahwa untuk itu kami juga siapin Pak Edi, artinya kami bekerjasama dengan PKTJ, dengan SCTD, dengan Bali, Potrada, untuk bagaimana menyiapkan para penguji ini untuk mampu melakukan pengujian-pengujian untuk kendaraan listrik yang terbaru. Kami selalu melakukan pelatihan-pelatihan, Pak. Kami sudah coba, baik itu Zoom maupun pelatihan langsung. Kami sudah menjadwalkan PEDI setiap hari Selasa Kamis pada waktu pukul jam 4 sore, maka semua penguji duduk untuk setelah melakukan pengujian untuk nge-Zoom, kami menyampaikan ilmu-ilmu yang terkait dengan kendaraan yang akan mereka uji, dan pembicaranya adalah langsung pada pabrikan yang menyampaikan materi-materinya, itu terhadap kendaraan listrik. Pada prinsipnya kami menyiapkan diri dengan kawan-kawan PEDI dengan tetap dengan bicara prioritas. Yang pertama yang pastinya mendukung program PTS, yang kedua terhadap PSPN yang kita wujudkan, dan yang tercepat adalah dalam rangka tahun depan kita mendukung kegiatan G20 yang insya Allah kita akan menggunakan kendaraan listrik dalam pelayanan sistem transportasinya di tahun depan. Itu kira-kira Pak Edi, dan kami juga sedang menyiapkan kurikulum terbaru dengan tadi Pak Tiga Diklat tadi, terhadap peningkatan kompetensi para penguji yang terhadap kendaraan listrik tadi. Itu Bapak sekalian, dan satu lagi jangan lupa, setelah kendaraan listrik, kendaraan BBG di kami masih tetap berjalan. Yang kedua, biodiesel tetap berjalan, bahkan kita menuju ke biodiesel nantinya bahkan bisa berani sampai 100%. Kami yakin itu, Indonesia yakin itu, mewujudkan kendaraan tetap bicara yang ramah lingkungan. Demikian Pak Bagus. Sorry,
terima kasih. Pak Li, because Pak Li mau leave sebentar lagi, and you've been addressed by Pak Rizal Wasal. Do you have any quick response to that?
Oh no, that's okay. Actually, the market of electric vehicle in Indonesia is actually different side. So we'd like to working together with the government side. So it's only it's a negative thinking, but we just maybe suggest some more the critical issue. So don't misunderstanding. We are actually very happy and then very thankful for the government support. So there is no argument. Yeah. Thank you very much.
Thank you, Pak Li.
Yeah.
Thank you very much. Pak Li harus pergi. We welcome you to leave if you have to. Thank you very much for your participation, Pak Li. Pak Rizal Wasal, terima kasih. On to the next question. Untuk Profesor Satrio Brojonegoro. Professor Satrio, you're also in your capacity as the president of Indonesian Academy of Science. So you interface between the government and the academic community and research community. You've got ambitious goals. By 2030, over 1 million uptake of EV. what are the challenges? And I'm not talking about general challenges. I'm talking about research challenges ecosystem. How ready our research ecosystem, universities, in supporting these goals, and what are we lacking in terms of battery, charging station technologies, and EV itself? Profesor Satrio masih bersama kami? Ya, oke. Mungkin kita lanjut ke pertanyaan berikutnya dulu. Profesor Satrio masih terkendala masalah teknis mungkin. So, moving on to a question for Pat, Professor Patrick Wheeler from M. Aziz. The question is about standards. So, there are quite a lot of testing standards for electric vehicles. Among them is electrical safety testing, ISO 17409, ISO 64693. What is the procedure for determining the safety standard for testing electric vehicles according to the climate and conditions in Indonesia? I know you're not Indonesian, but what do you think would be the right procedure for determining the safety standards for testing electric vehicles?
By testing, are you thinking of testing new vehicles for the environmental conditions, or existing vehicles for continuing safety?
Here's what I understand. And in Indonesia, for four-wheeled vehicles, we are currently under the process of testing safety standards. But what do you think would be, according to your insights, the right procedure? So for determining safety, would the battery requires more scrutiny, or the thermal management? What would be the right procedures?
Right. Okay. So the first thing I would say is that there's already a raft of very good, generally international standards for batteries, the housing of the batteries and the drivetrain and so on. So the parts of an electric vehicle that are generally unfamiliar, and that those ought to be applied. Now, it's very easy to think that the climatic conditions are different in each country. But when you're looking at an electric drivetrain, you're really looking at the ingress of dust, of water, and so on. And those measures exist in a lot of countries around the world. So one of the things with electric vehicles is to bring the cost down. So one thing I always say is the best thing to do is to make sure we pick up on the right international standards for each country, and that we apply them across the world. We don't want, it would be counterproductive for electric vehicles if different countries adopted different standards and different testing techniques. And that's the whole purpose of the international standards. And there's a whole raft of them. I know we've given presentations on those recently. So one thing I would say is, sticking to the international standards and looking at those international standards and making sure that they give the right vehicle protection for the conditions. But we get a lot of standing water in the UK. It's a different temperature than the standing water in Indonesia, but the ingress problem is still the same. I say that looking out of my window at the rain today. So I think that there's a lot of things there that will be international. And in terms of things like the battery safety, which is one area of obvious concern, it's where you have the stored energy, therefore that stored energy can escape, and it tends, if you get it wrong, it escapes in the form of fire. We see that with petrol as well. Those things, again, the international standards are developing, and making sure that all countries are involved in that process is a critical part of that. So it's not going off in their own direction, but actually everybody getting involved in that standards process, because it is still evolving, and new things will happen. The final thing I was going to say on this is that our standards needs to be open. Why do I say that? Well, we've spent decades, 100 years, developing the internal combustion engine car and the systems to go around it. For example, we use friction brakes. So we use lots of energy to accelerate a car, and then we lose all that energy as heat in a friction brake. What a waste of energy. And in an electric vehicle, it's very easy to recoup that energy and put it back in the battery. It's very easy to create a negative torque on a wheel and to recover that energy. But that means we need to think differently about the braking tests for vehicles so that we allow those technologies to develop and allow them to develop in a safe way. So when we are writing new standards and when we are considering standards for electric vehicles, we've got to forget our prejudices about how things are done today and make sure the standards are there to test the things that actually affect safety and aren't mandating poor, low quality energy in terms of energy use technologies like friction brakes. So that would be my final thing, is thinking of standards, be very open to developments you don't yet understand.
Indeed. Given our condition of our traffic, which you will otherwise encounter hadn't it because of COVID, we would both be in Indonesia by now. I think regenerative braking requires a little bit more scrutiny there, because I remember my times in Indonesia, I brake a lot. So yeah, all right. So thanks very much. So the next question is for Dr. Tony Parry. Instead of road infrastructure factor, which you talk about a lot, what about other factors like human factors, ergonomics vehicles, and their contribution towards safety? You think? Do you have any insights on those other aspects?
Well, it's not my area of research expertise, so I ought perhaps just to say no. But it's clear already, I think, that I think it's clear already that for pedestrians and other road users, then the issue of being able to hear the vehicle approaching may be an important one. But I do think we need to ask us, and maybe not so much for electric cars, which it seems to me drive in a very similar fashion to internal combustion engine cars. I might be wrong. But I think in terms of e-scooters and electric bikes and things like that, these are really, it seems to me that they might drive very differently to the ones we're used to. And therefore, I think that the ergonomics and the human vehicle interaction are very important indeed. Yeah. And I think we need probably, and until talking outside my area of expertise here, but we probably need to take similar approaches to those we've taken for what we consider to be standard vehicles. We need to be looking at accident statistics, but those accident statistics are only going to grow very slowly as these vehicles are introduced. So there are statistical studies to be done, but there are also studies to be done using driving simulators and things like that, and test track trials. Something I would say then, related to the presentation I gave, in the UK, the traditional approach to accident analysis, looking at statistical relationships, is that where we've been successful over the decades in reducing accident numbers, looking for statistically significant relationships between accident rates and traffic characteristics or geometric characteristics of roads, etc., it is becoming more and more difficult because we have fewer and fewer accidents. Most of the accident black spots have really been dealt with from the point of view of road safety. So the idea then of being able to collect the sensor data from modern vehicles to look at what that can tell us about accident risk before accidents actually happen. You know, where accidents haven't happened, but where there has been driver behavior like very harsh braking or very harsh cornering or very harsh acceleration, etc., which might indicate an accident risk. Even though the accident hasn't happened, collecting that data and analysing it, I think will be a very, very important way forward.
Thank you. Yeah, data-driven analysis is really important. But I can speculate too, because I heard that although I don't own an electric vehicle myself, it's very quiet. So I don't tend to be aware when there's EV around. You see, there might be some implication on safety on some other people who don't know there's a EV in their vicinity and get crashed by an EV. But that's speculative. But I take your point that a data-driven analysis is indeed needed. Thank you. Thank you very much indeed. So the last question is directed to Pak Zulkifli Zaini. Sorry, from the anonymous to Pak Zainal Arifin. Apologies. Now, so the question is from anonymous. I'm just going to wrap it up because it's rather long questions and our last questions too. The question revolves around skepticism. Gas and gas stations is ever present in Indonesia. It's everywhere. It's convenient. Everybody knows about it. We got a progressive goal, though, quite an ambitious one too. Indonesia is an archipelago, unlike the UK. You want to put charging station everywhere. Do you think this would be sufficient, these initiatives, to convince the public to change to EV? Looking at the way it progressed now, do you think the number is up to the task? And do you think it will be in 2030, 2040 moving forward? And what do you think needed to convince the public?
Okay. Yeah, I think this the main challenging issue we have how we do the education, how we do socialization about the right thing about EV. For example, some of us still thinking EV like ICE. So for fueling, for charge the energy should go to the gas station. But EV totally different. You can do charging at your own home. That's why in Indonesia, I have a good example. In one region in West Papua, there is a village. All the vehicle use two-wheeler electric vehicle. Why? Because they much easier for getting the electricity than the fossil fuel itself. That's the key actually, because like our mentioned that we should also change the mindset. Comparing to the gas, to the fossil fuel, they will depend on the infrastructure, on the facility. But actually, if we have the electric vehicle, if we already subscribe the capacity enough, we can do the charging at our own home. But why we still should develop public charging? The public charging is needed by we call it the highly mobilized vehicle, like fleet operator, like taxi. They do traveling maybe a day more than 300 kilometers, so they needed the public charging. But for myself, for some of us, we actually not absolutely need the charging station, because we only drive our car by our own home to office, maybe only 80 kilometers, less than 100 kilometers. And after that, park to the garage at the time, maybe for 6 and 8 hours. During the time, the parking, we can do charging at our office. So after that, we go home. And we also can do the charging at our own home. That the basic mindset, the difference between electric vehicle and ICE. So I believe that our roadmap is sufficient for developing the EV community, EV ecosystem in Indonesia. At the beginning, this is the classical problem. We will have the egg and chicken problem. Some of EV owner think that where is the charging? But we already built the charging, and we also ask back, where is the EV electric vehicle? So that the problem should be solved. Why the government asked PLN for the first step to provide the infrastructure, because this is mandatory. This is not about the commercial thing, because the first step, everything at the beginning of adoption, innovation state will be like sunk cost. Yeah. We don't think about the commercial yet. Yeah, but we should change the mindset. This is the most important thing, that the EV is totally different with ICE. Yeah, I think that the main challenging for us in Indonesia, and also the main challenging issue, not about the supply, not about the infrastructure, not about the behavior, but if we realize to the market, the price of EV is still not affordable for some of us. Yeah, that's the problem. So we should create the market. Maybe at the beginning we should create the captive market. I think that's my answer.
Well, that's a very good answer. I think, in the UK, we have a lot of research also, so-called vehicles to grid research. And this is also something that Nottingham University is paying a lot of attention to. So electric vehicle is not just for the sake of moving from one point to another point. When not in use, it could contribute some of the electricity back into the grid, and which probably become a very modularized solution for Indonesian context. And also, when the electric vehicles stop operating, some of the battery can still be used. Do you think PLN has any idea about the Purna Guna utility?
Yes, indeed. Yeah, we will have planning to utilize the second life of the EV to be a battery energy storage system for powering the electric vehicle, power system. Yeah, especially for the hybrid. We will combine the diesel with the renewable energy, such as PV and wind turbine, with the battery, not new battery. Maybe the second life battery coming from the EV battery.
Which would partly solve environmental problems too, right? So because you don't want it to go to waste and pollute the environment.
Yes.
Exactly. Zainal, yeah, we have a lot of research in that, not only in Nottingham, but other universities in the UK, very open for collaborations in research and development moving forward.
Okay, we are very welcome. Yeah, we are very welcome for everyone to developing the EV infrastructure and EV related matters like battery utilization after the EV battery is maybe lifetime is coming. Yeah, we are very welcome for that.
Thank you very much indeed. That's the end of our main presentations. I'm going to welcome now Dr. Siti Maimunah, the Director of PKTJ, Politeknik Road Transportation Safety, to wrap up the points of the discussions and give us some closing remarks. I would like to thank again all the participants. It's been lively discussions. Apologies for those who haven't been able to ask questions. The number fluctuates between 600-700 to over 1,000 today. It's a very large event indeed. So without further ado, because it's quite late in Indonesia, Dr. Siti Maimunah, can you hear me?
Sure, Mr. Pak Bagus.
Right, please. So time is yours now. And thank you very much indeed for everyone listening.
Okay, thank you, the Honorable Head of the Human Resources Development Center on Land Transportation, Mr. Imran Rashid, Honorable Director of Road Transport Facility, Mr. Rizal Wasal, Distinguished Chairman of Indonesia Electric Vehicles Acceleration Program. I hope Professor Satrio Sumantri Brojonegoro still here. And distinguished representative of Nottingham University, Professor Patrick Wheeler and Dr. Tony Perry. Distinguished Vice President and COO of Hyundai Motor Asia Pacific, Mr. Lee Kang-hyun. Distinguished Executive Vice President Engineering and Technology of the State Electric Company, Dr. Jainal Arifin. Official of the Ministry of Transportation, Mr. Moderator, Pak Bagus, distinguished participant, guests, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. May the peace and blessing of Allah be upon us. Salam, Om Swastiastu, Namo Buddhaya. Excellencies, distinguished guests, ladies and gentlemen, I'm delighted and honored by the opportunity to address we finally have to come to the end of the international webinar on safer electric vehicles. Various aspects of electric vehicles have been discussed, including the vision of electric vehicles in Indonesia, regulation on electric vehicle inspection, electric vehicles battery charging, and also about the infrastructure, and also the valuable insight from the industry regarding the development of electric vehicle technology for now and later. For the Politeknik of Road Transportation Safety, PKTJ, this webinar activity is the first step for us to take part in the electric vehicle acceleration program in Indonesia. Therefore, we still have a lot of things to do, especially research on safety aspect of electric vehicles, as well as also have a lot of compiling on education and training curriculum for preparing the competent, skillful, and also the provision human resources and to execute the electric vehicles inspection. And also in order to ensure that every electric vehicles in roadworthy and technically qualified. And for this reason, we really hope for your support, input, and also cooperation to realize a safer system and standard, particularly in electric vehicles. On this preferential occasion also allow us to express our gratitude and high appreciation to the Minister of Transportation Republic of Indonesia, Mr. Budi Karya Sumadi, who has given direction and support to this international webinar on the electric vehicle acceleration, and also the program for the electric vehicle acceleration in Indonesia. Mr. Desra Percaya and Mr. Rofen, who has given remarks and support in this webinar also. Our respected speakers who had presented very valuable materials for us in this viewpoint of the electric vehicles acceleration program and its implementation in Indonesia. And the moderator, Dr. Bagus Mulyadi from the University of Nottingham, who has guided this event very well, as well as invited guests and all webinar participants who have attended and provided support. Hopefully it can provide great benefit for all of us. And then we really hope this webinar will give a real contribution to the implementation of the electric vehicle acceleration program in Indonesia in order to improve the energy efficiency and also energy security, as well as the conversion to the transportation sector and create the cleaner air quality, as well as to reduce the effect of greenhouse gas in Indonesia. And a very important objective is the realization of safe road transportation system, including of safe electric vehicles. Therefore, we can participate in realizing a road transportation system which is safe and environmentally sound in Indonesia, in the United Kingdom, and also throughout the world. Before I close my remark in this afternoon webinar, I will give you a written poem. If you grow apples and lime, don't forget to harvest in May. I thank you all for your presence and time and wish you all a great day. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore.
Waalaikumsalam. Terima kasih.
Salam.
Thank you, Dr. Siti Maimun, SSC MSA MF, for the closing remarks. We would like to thank to all presenters who have delivered very useful information, as well as to moderators who have guided the presentation and discussion on the international webinar. His Excellencies, distinguished delegates, ladies and gentlemen, we have now come to the end of our today's event. All participants may proceed to leave the meeting room. Again, thank you all for your presence and have a good day.